Hey, Joe. Actually, I did get quite a few good food deals lately. Oh. Ibotta has $1 off on Smithfield sausage, and they have 4 flavors up there that are separate, and you can use each one 5 times, and it recycles. I've used them 3 times already. I've got like 30 sausages in the freezers. So they are $3.28 each, and they're 13 ounces. So that's about $4 a pound. Then he gets $1 off. You get a pretty decent sausage for $3 a pound. Uh, because you could use each flavor 5 times, that's 20. So you could buy um 60 bucks worth of sausage and get 20 bucks off. And that's usually also enough to get you some of the midweek or weekend bonuses. Like the one time I got an extra $10 off for the Hocus Pocus bonus. So I literally got 20 pounds of sausage for half off. Like, I can take that. Yeah, that's a really good deal. $2 a pound for bacon's insane. That's an exceptionally good deal. Ooh. Ah, okay. Wasn't that interesting? Oh, it comes. Oh, it actually comes with one of the switches I ordered. Yeah, $2 a pound is a fantastic deal. The switches that I'm waiting for to come in the mail, they're part of this flashlight. That's the same switch. Okay, so I got one switch. How does this work? That's got to be the. I don't know if this is positive or negative. I'm guessing that's negative. So this would be positive, this would be negative. Okay. The bulb is actually part of this module instead of part of the lens assembly. So I have got to liberate the bulb from this and make it part of that. And then use this in my flashlight head. This little dollar store LED flashlights. Okay, it's not too bad. So I just need a little hot glue, make that into an assembly. And I just have to design for this. So I can keep a little lens assembly. Nothing recent, just the flashlight I'm working on. And I just lost the lens. That is 40 millimeters. How big is it up here? Oh, I forgot how high I gotta make it. So 40 millimeter hole for that. Then I also got these for area lights. And then I also had this little headlamp assembly, which seemed pretty neat. Guessing this pops off. Yep. That's actually not a bad design for a cheap dollar store item. Oop. I keep losing bits, I don't care. Now, the only thing I don't like about that is I might not be able to make that a simple on-off because it's got a chip. I'm guessing there's a chip in there that's allowing me to have those different modes. So let's see what happens if I unplug it. Oh no, it does turn on and off. Oh, nope, it turned off that time. If I'm fast enough, it does just unplug. This one might require me to leave the little circuit intact. No. Oh, that'll never happen. They'll never accept me in Divine again. That's a one and done kind of deal. Okay, now I want to take this apart. Obviously there's a reason they won't tell me. Sometimes I think they just want to cycle through people. I don't know, but they didn't give me a reason. Okay, that gets rid of that. Yeah, there's a little IC on board there, which means I would probably need to keep the switch. There's my connections. There's the positive. There's the negative. I wonder if I can bypass the switch and drive the LED directly. That was easy enough to remove. That was easy enough to remove. Now the chip should pop out. Not really anything holding it in there anymore. Probably need to fish out this part right here, since the switch is soldered to the board. Nope. That should allow me to push out. There we go. So there is the LED board. That's a nice little ideal board, but I don't want the switch. I don't think I have a choice. I don't see any exposed contacts to access the. Hey, Joe. Photo minima. So I don't see any way to bypass the IC. At least not without messing with surface mount. Probably the easiest thing to do would be to resolder the switch so that the switch is facing this way, so that when I embed this into the print, the switch is exposed for me to press. That'd probably be the easiest thing. There are leads on the switch, so I should be able to desolder the switch and then resolder it in facing up. And then that would actually be a pretty nice little area light for the flashlight. I like that. Pretty simple to take apart too. And if I remember correctly, this one up here is positive. This one down here is negative. I want to tear apart one of these. These are pretty neat. They're not like the brightest in the world, but they don't need to be. They just need to be usable. Some of the components came in. That's just an on-off. There's no high-low, so it should be pretty easy to rearrange that to allow me to turn it on and off. Hello, Timothy. Now, how do I tear this apart? Do I just pry this out? It's tearing apart. There we go. Ooh, this one's got wires. Very, very tiny wires. Wires that are so fun to strip. Oh, switch comes right. Oh, wow, there's not much to that. That just pops right out of there. Oh, wow. And that would be very easy to mess with. Simple, negative, and positive. That's a tiny little module. And another one of those switches. Looks like China uses the same switches that I'm going to be using. Wow, that is tiny. I was not expecting that to be quite so tiny. And easily hackable. Oh man, that's so easy to hack. Pretty good, Timothy. I love how absolutely hackable this is. Look at that. In 10 seconds, I have a switch and an LED module yanked out of that thing. Not bad. Oh, that is very, very cool. So there's my two area lights. This can maybe be a front-facing wide angle light, and then a couple of these make them into a the focus light. Not bad. The only thing I don't like is I don't know how to run this without the. Hey Matt, I don't know how to run this without the. I mean, there probably is a way to do it, to run this directly off the battery without going through the little switch. Although I could just. No, this is a momentary switch. This is not a on-off switch. So this is a, high, low, strobe, off. So it cycles. Meaning using the existing switch contact points, I don't think I can run this off of a simple momentary or simple on-off switch. Which is too bad. That's a nice little module. I like that. That's actually a surprisingly nice little headlamp for a dollar store. It comes with a little elastic strap. That's actually a surprisingly. It's got an IC on there. There's two actually capacitor, resistor, capacitor, IC, plus the switch. That's a nice little fab for a dollar store. Normally you expect this kind of stuff. So LED with a resistor going right to the contacts that touch the warp core. The little warp core these things come with. So these are designed to work with something like this. It's actually not a bad light. There you go. It actually produces about a 6-inch spot of bright light and about a 1 foot, maybe 18-inch spot of dimmer light. It's actually not, for a dollar store, that's actually not bad. So I'm going to use 2 of these. But again, very hackable, relatively easy to take apart. Everything just slides apart. I'd really like to make this work with an on-off switch. So now we're going to go back into Tinkercad. If I got to make this a window so I can see your guys' chat. Bring this up so that my video that you guys are going to see right here. Okay. So let's bring this down to 0. Then we want to align this. Okay. How tall is that? That is that tall. $11. So if we make the face 2 millimeters thick, that's 3 millimeters thick. That leaves us with 8 millimeters of height. So our lens is 40 millimeters. Let's go 2 millimeters for a 9 millimeter differential. We're going to go right about there. $15 millimeters. So this is going to have a top radius of 7.5 and a bottom base radius of 20 and a height of 9 millimeters. That's totally wrong. So we're going to delete that. I must have scaled that at some point. That means we need to go back down to here. And we need to bring this to 2 millimeters in height. And we're going to increase the number of sides. Top radius 7.5. Bottom radius 20. And a height of 10. The height's going to have to be taller. Let's make it 12. It's got to punch through this. That's still not enough. How thick is this? Let's make that 2. Excuse me. What am I doing wrong? I did something. Oh, I did do something wrong. This is already height. Okay, so it needs to be taller. This needs to be 13. So 14. Now this needs to be remeasured. Come here, baby. Almost to the top. $16. So a radius of 8. There it is. Okay. Wait, did I correct that? 2 millimeters. 2 millimeters. Okay. I'm probably going to want that to be 3 millimeters. Because 2 millimeters is really thin. Okay. Let's hide this for now. Make this a solid again. No, keep it. No, keep you solid. Keep you hollow. There we go. So we're going to want 2 of these. Probably right about there. Let's join these together for now. And let's do a center. That looks good. That looks good. It is far enough away from the pins. Okay. So the next thing I need to do is to unbond these. What? What's the matter, baby? Yeah. Hey, Chow. Chow. Cats are hungry. Come on, babies are hungry. Okay. So now let's make another tool. 3 millimeters. So that we have a way of making a work plane. And we need a cylinder. Oh, poor kitties are hungry. Okay. First, we need to stop using purple. It's a horrible color to see. It has no depth, contrast. Okay. And we are going to make this 40 by 40. Okay. That should line up pretty easily, and no, it won't. Okay. Okay. All right, the next thing I need to do is put the work plane back down here and create another cylinder. Okay. Now this one is going to be smaller than this. we're going to make that 32 millimeters. .32 by 32. And you were going to go there. And you were going to go there. Now what we need to do is we need to select these three, align them, freeze that part into place, align that, and align that. Okay. Now we take this piece and this piece, join it together, make it into a cut tool. Then we do the same thing for this one. We align, we freeze this as the anchor, center and center. Then we select this piece and this piece, join, make hollow. Okay, now we have our cutouts for the lens and the holes. So now what we do is we bring the pieces back, turn this into a solid, we select this piece, and this piece, and this piece, and we cut them. And then we take this piece and this piece, make them a cut tool, and they cut into this. There. Raise this up so it's not in our way, and there. Now we have the cavity that these two lens assemblies will fit in. And then this is the retention plate that's going to hold those two assemblies in place. So we'll super glue the LEDs to the assemblies, but we'll only one wire will have to go underneath, which is fine. Come out the other side. So the daisy chain them together. But that should work. Yeah, that should work. Yeah. Still have to order the charge controller. Haven't ordered that yet. Okay. That cat's giving you hell. I said, that cat's giving you hell. He's like, come on, feed me. Now I could also make this look a little nicer. Oh, that poor cat just wants to be fed. And you're just torturing him. Okay. So, flashlight head. Let's export that. Flashlight retention. Worth that. Then body. Okay. Let us make this a separate object. Let's copy this. New. We're going to call it not a Dollar Tree flashlight. Okay, there is the assembly. Come back into this. Now we should be able to. Oh, I can't do that. I would have to do it this way. Okay, that returns the plate to stock. And delete that. Delete that. That returns my flashlight head back to a stock configuration. So I should probably just take this whole body and bring it into the other program. This way I don't lose my history. Okay, there is the body. It looks intact. I don't see any problems. All right. Now, how big are these? Where is it? Oh, yeah. These are super tiny. That's right. These are super tiny. These are 20 by 10. No, not quite. 20 by 13. So, how do I want to do that? I mean, ideally, I would run a channel over there. And ideally, I'd put one on each side. Or hell, put 4 of them on there. I could even put them behind a diffuser panel to soften the light. So it's not so harsh. Basically, I want to be able to stand this thing up as an area light and have 2 here and 2 here, and this thing would just light up an area. What's the best way? Let's get the thing designed out. So it's going to be 13.2 that way. And it's going to be 21 that way. Let's assume 2 millimeters tall. So that's approximately what we're looking at there. So if I stand them up like this, pretty easily put 2 here. Just like that. Do that. I have to bring it down a bit. Hey, that isn't centered. How is that not? Oh, I centered it on this opening, didn't I? And not on the whole entire body. That's. Why would I have not have centered that? I have no idea why I didn't center that. It doesn't matter now. But yeah, I could put 2 there, and then 2 on the other side. I've got enough room to sink them in pretty far. Can I play around with one of these? No, I cannot make a squared off top. Not easily, at least. How do I want to deal with that? Yeah. Okay, so if we do that, here we are. Do a -3. No, that's wrong. Why is it doing that? It's doing this surface. That's why. This. Do this. Then do this. There we go. Still wrong. Why is it doing it wrong? That's 0. But that's not 0. I mean, I could see the damn gap. Why is this not working? This should be There it is. Now it's working. I don't know why that didn't work at first. Okay, so 3 millimeters off the surface. That's what I want. Down a little more. Of a hose heater. Okay. Now what I need to do is to put something like this into place. Oh, car? Geo Metro? I believe I have it at 13.2 by 21. Yeah. Now that I have that, I should be able to simply scale it. I think that'll work. Let's unselect that. Take this and this, align, fix this and this, and unselect, select, Control D, bring it over here, this and this, align, freeze this one, align. Take this and this, join them, turn them into a hole. Okay. Now we take this and rotate it 180 degrees. Take this and this. We join them together, make them into a hole. Take this and we join it with this. That gives us our holes for the lights to go into. Then we put a floor down here because we're going to have to cut this later. Then we sink these in until we like what we see. So that lines up with that. Let's go down to 0.1 millimeter. That looks good to me. Yeah, that looks really good, actually. Yep, I like that. Now we turn them solid again. We add a tool here. We are going to make cover both of these, and then we're going to invert it. And then we join this with this. Then we turn this back into a hole. we're going to keep a copy of this. Wait a minute. If I turn that solid again, if I put a surface on here, I can make this really easy for myself. Okay. We will have to hide this so that I can grab this and join them, and then unhide. There we go. And take this, bring it up. Turn it into a hole. Yep, I can live with that. So, Control D. We put a copy of that over there. Make sure it's outside where I can see it. Yep, there it is. Oh, I didn't get it all. It's in the middle, so it doesn't matter. We rotate this around 180 degrees. We bring it into the surface over here. That should do it. Should be able to select all that and get rid of this. There. Now we have two recessed beveled cavities for light on this, the lights on this side and the lights on this side. Okay, I can live with that. Okay, I could do another Control D, can't I? Nope, that didn't work. Okay, I like that. Now what I also need to do is to put a recess in here. I can do that later though. I want a recess in here so I could put a lens over top of this to make it a diffused light. But for now, let's leave that alone. Okay, now what I need to do is put a hole. I gotta poke a hole in this. Let's make a 5 by 5 millimeter hole. Let's join them together. Then punch it through to the other side here. Okay. Okay. That'll work. And that'll bring the wires inside. So these need to be 5 by 5 by 2.5. See here. A little more sharp. Come on. That looks good to me. Punch all the way in. Well, that's awfully tight. No, I don't need to punch all the way in. I just need to touch this. Why won't you move up? That'd work. So D. Flip. This way. Yeah, I can live with that. Now we have a channel for the wires to sit in, so it doesn't interfere with putting the batteries in. A little bit of hot glue or CA to hold the wires in place and you're good. But now we have a place to put 4 of these little lights. So we have area lights. I wonder, should I have 3? So put one here. But nah, we're getting too involved at this point. Okay. Yeah, that works. I think I can live with that. Let's copy this. Of course, caps lock is on. Okay. Something else I'm working on is I found somebody locally who's selling these things. So it's glass, I'm guessing, or plastic, but it's a solar LED light that's in a hot air balloon. Hot air balloons are a big thing around here because they have a balloon festival in Albuquerque. So I decided to try to make one. And it's giving me a hard time. Because I've gotten to the point where I think it's this one. Finally got the piece made, and I've gotten to the point where I can't edit it in Tinkercad anymore. Like I'm trying to clean up these sides, and it just won't do it. And I try to export it and then re-import it again to simplify it, and it won't import it because it now exports over 25 megabytes. I found some programs to simplify it to reduce the polygon count. I got it down to 3 megabytes, but I still can't re-import it into Tinkercad. It's basically now it's too complex a shape to bring into Tinkercad. And there doesn't appear to be a whole lot I can do about it. Although I do think I have a usable part. So obviously I have to do this with PETG because I need it to be transparent and I need it to be temperature stable. But I'll print out 16 of these, 8 pairs. And I also have it's not in this model, but I also have the top made where all these join together to form a balloon. And I still have to make the basket. But this thing is big. It's just this pedal is this is half size. So it's double this. I tried making it smaller to see if that would help. I have to print the pieces on the Chiron. I don't think I can fit it on a 3.3. I need a 4.4 bed to fit it. But they're going to be it's going to be like 24 inches tall. This piece here alone is like 14 or 15 inches tall. So it'll be interesting. Yeah, 325. So that would be 13 inches tall just for this pedal of the balloon. So that'll be interesting. When it's done, it'll look something like this. I already got the lights for inside. I got the little mason jar light with the little dangly lights. So actually, there's a cavity in top here where that'll fit. Yeah, no shit. Come on. Let's see here. Here we go. So there's the piece, and it's 350 millimeters tall, so it's 14 inches tall, approximately. And then here's the joining piece up top. So each of these pedals will fit inside of here, like that. They'll just glue in place. And then the solar light unit will fit in the top here. I'll probably cut this in half and print it in 2 halves and glue them together, because that would be a messy print right there. Yeah, that would not work. I could make it work. Now that I think about it, I might be able to make that work. Because what's inside here doesn't matter. I can make it a cone. I mean, this would still be a pretty nasty overhang here. But it would be nice to print it as one piece. But anyway, the solar light would go into here. So the way this would work. This would go here. Blender is more art-based and not really dimensionally based, so Blender probably wouldn't work for this kind of a project. The advantage of Tinkercad is it's free and it's intuitive. It's WYSIWYG. Oh, that doesn't fit anymore. Oh, okay. I messed that up a little bit. I gotta reshape this. Yeah, that doesn't fit anymore. Oh, good thing I checked. This is gonna have to be scaled. Actually, I can't scale that because it has to hold the solar light. So I gotta change the tip of this to fit here properly. But that will go like that. Um, that would go something like that. Oh, let's join them. I think it's 22.5. Yeah. There. So that would look something like that. Tinkercad's really struggling to display this. A solar light would sit on top of there. And then you'd have a balloon. I just have to design the basket for it. Now what's cool is that I can also, print them in pairs. So for example, I could make multicolor. Boy, is this struggling. So for example, the first one I'm going to do is going to be alternating yellow and red for New Mexico colors. Like that. Wow, is that struggling? That's exactly what it's going to be, Chad. It's gonna be print in PETG, so that it can handle being outside, and it's going to look like that. And I've already got the solar lights to hang in the inside. So this cavity right here is designed to accept the mason jar solar light. But yeah, I'll just print these in pairs in whatever colors people want. Well, based on what colors I have, of course. But if I can sell one or two of them, then I'll have enough money to buy a few different rolls of PETG, and then I'll be able to offer a larger color variety. That was not super easy. I can't edit this part anymore. This part is no longer editable. It's too complex for Tinkercad. But yeah, they get complex pretty quick. But now I still need to design a basket for it. I also have to put hard points in the top piece for eyeballs so you can hang it. But yeah, that's the idea there. Wow, Tinkercad is really not enjoying this. Look how slow it is. Yeah, the nylon cord, paracord, basically. I got. Jesus, knock it off. Hey, the battery's finally shipped. But yeah, I got the light units for this in. So it'll be simple drop in place. Literally just stretch the light out, drop it in there, done. So that making this LED lit would be nice. This is probably going to be close to 75, $100. It's a lot of printing. Um, this balloon here, just this balloon portion here, is 14 inches tall. So it's going to be about 20 inches tall with the basket on the bottom. So it's going to be a big boy. And it's going to take a lot of plastic. But go big or go home, right? So it's going to be a big boy. It's going to be bigger than this. And this sells for 78. And it's going to be bigger than this one is. Now, what would be neat, and this would add cost, of course, but I think it would be cool, is if I can get a flickering flame LED to put in the basket, so it actually looks like a hot air balloon. I think that'd be kind of cool. But that'll come later. We'll see. So I've got the top almost done. Well, I want to make it myself. I would really like to make a rope style basket. I think that'd be pretty cool. I could probably find something on Thingiverse. Just gotta find something nice enough. I want it to look pretty nice. But I'm hoping I can do this for under $100. Because I think it'd be a hard sell above that. So we'll see. Let me undo some of these. There would be the inside. So that'll be interesting. I need to make one more edit to it, and I don't think I can. The software won't let me. I gotta figure out how to make that one last change. But so I'll have to print out 16 of those, one of these, the basket, and go from there. I still have to either edit this or figure out a way to get these points off here. Ooh. when I merged it, excuse me, I got these points that I got to get rid of. They're going to cause a problem. Probably the easiest thing to do for now would be to print this as it is and then just take a snips to take off those little corners. And I can print these in vase mode, so they're about 2 hours, 2.5 hours each print. So 16, that's 32 hours of printing just for the blades. This is probably going to take another 5 or 6 hours to print. So I'm probably looking at a full 2.5 days of printing per balloon. Obviously, I would use a different printer to print the basket and a different printer to print the top here. So I'd have one printer just cranking out these. So every, 2.5 hours. Kira's a pain in the ass. Yes, it is. My favorite is Simplify 3D, but I can't really suggest people buy it since there's probably never going to be an update ever again for it. So your best bet is going to be Idea Maker or Prusa Slicer. Those are both decent slicers that are being actively updated. So if you're going to learn something, play around with Prusa Slicer and play around with Idea Maker. I hope I can figure out a way to use this one. I really like this LED. Just gotta figure out how to drive it directly, without the silly little switch. I'll figure something out. I'm blown away by how easy it was to take this apart and get this LED out. And I get switches that I need too. I get 4 switches and I only need 3. So I don't need to buy switches anymore because when I buy the 3 lights to get these modules out of it, I get the switches that I need. That's kind of cool. So now I'll have 100 of those switches and no need for them. I'll find other projects to use them on. I got $71 in Amazon gift card from Ibotta. So I used that to buy all the widgets that I needed on Amazon. I got the wire, the switches, the batteries, little soldering iron. So I got everything I needed except for the charge controller. I still have to order that. I have one here somewhere. Just gotta find it. But yeah. Let's go out of here. Oh, can't do that. So I think this is done. I think I have all the pieces I need, or all the models I need. I should be able to print these. I got the JST plugs. I got wire coming in. I got the batteries coming in. I just gotta find the charge controller. So I think that's it. I think this is ready to be printed. The only change I might make is I might put a dimple in this one here. Might stick a dimple in here so the wires can move between the two. There. Now there's a channel for the wires to move in between the two halves. See, head, export, change it back. There. So now there's a channel for the wires to move. Oh, I do still need to get some M2 screws for all these holes, if I don't have any. So the two reflector assemblies will go into here, get wired together. This will come down on top, get screwed into these 4 holes here, and that will hold the reflector assemblies into the flashlight head, making it into one piece. That will have a JST plug on it. The batteries will go into here. Power conduits go here. The USB-C charge controller will be here. The switches will be here. So one switch to turn on the flashlight head, one switch to turn on the side lights. I'll probably have 2 switches for the side lights, maybe. So I can have just one set on, or I can have both on if I want to stand the thing up. I think that makes sense to have 2. Yeah, so 3 switches. One to control this set of lights, one to control this set of lights, and one to control this set of lights in the head. 2 5 amp hour lithium iron phosphate batteries will go inside here. There's enough head. There's actually enough space for 3. I'm gonna put 2, and then the head space will hold all the wiring. This channel here is enough to allow me to slide the switches into place. So the switches will slide right down inside of here and then get secured into place. I still have to design a cover for that. I thought I did already. I'll have to check the other model. But a cover plate like this will go inside of here with screws, and that'll hold the switches in place. Although for the prototype, I'll probably just glue them in place. Why overcomplicate it? Here's channeling for the wires from out here. Screw holes already in place to screw the flashlight head into place. Yeah, I think we're good. So now I just got to print these parts and assemble it once I have all the pieces in. That works. I can make that work. I don't mind the screw head sticking out. That's okay. I mean, to make it cleaner, yeah, sure, you'd want to recess them, but if I'm using Phillips head screws that have the built-in washers that are mushroom heads, they're going to be smoothed on the top. They'll be rounded, so it won't be an issue. Screws like this, Yeah, screws like this would be fine. I'd rather have mushroom head instead of I don't like this kind. This is what I need, but I don't like that kind. That will split the plastic. Here we go, head style. Domed. Hmm. No, I don't like this. M2 screws. Here we go, domed like that. There we go. This way they'll just sit in there and not split the plastic. This recessing them's a pain in the ass. I bet you M2x6 would be good for everything. Yeah, right there. See, nice rounded top, so it's not going to catch on anything. 6 millimeters is plenty of thread. I'll add that to my cart for now. Slow shipping though. Why is the shipping so slow? If I go to M3, I can have them tomorrow. But I don't know. I don't want to redesign everything. 2.5x6. That'd probably be the best 2.5. Yeah, I bet you that'd be perfect. So each flashlight, I need 4 for the plate, 2 for the head. That's it. I only need 6 for each flashlight. Yeah, basically need 6 for each flashlight. I mean, in theory, I don't even need screws for this. I could just glue that down. 2 dabs of hot glue, and that's never going to go anywhere. But I like the idea of being able to take it apart. Yeah. So now I got to slice these up and cue them up for printing. can't think of anything else I need to do. I need to get 2 more of these lights. That'll get me my switches too. And then just start soldering. Well, I gotta wait for the wire to come in. That'll be here tomorrow. Plus, I don't have a whole lot of plastic here. There's not a whole lot of plastic there to be recessing that screw. I've only got 2 millimeters of plastic there. Okay. That can work. Let's see. Go in folder. There is the 3 pieces right there. Get rid of this one. There is the, nope. There's the body, the head, and the retention plate. See, we're going to use the CR6 SE. Nope. 0.4, 0.96. We go down 0.95. All right, body first. Don't see any issues. Oh, 17 hours. That seems way longer than it should be. Let's go to 0.24 layers. Bump the speed up to 60. That's more like it. 13 hours. That should not be doing that. Fine, avoid crossing. All right, that's okay. Yeah, that's enough infill. Yeah, I can live with that. Flashlight body. Let's do the head. hours. I am okay with that. I do want to fix the start point. That is not obeying. Why are my start points random? Why do I have start points here? It's less than 0.8 millimeters thick? It would have to be to cause that. Hey, RC Voodoo. No, but we do have some, we have 3 perimeters, but we have some thin wall behavior going on there. Let's go with 100%. There we go. That's much better behaved. We can fix that a little bit. Let's make it, it's going to be 0.72, so 0.8. Let's do 0.72. Come on. Okay. Center this way. Join. Flashlight head, export, STL. There it is. Delete this flashlight head here. Okay. Ugh. Okay.
Yeah, because she do her side.
Much better. So now, there's a little trick I do with my prints. See, normally, this would be 3 completely separate pieces of plastic printing. You'd have the 3 perimeters of the outside, then this would have 3 perimeters, and then this would have 3 perimeters. And the point where you jump from here to here or here to here can create a problem. Well, now I've made this one single perimeter for the first 3 layers. So if you look here, it's going to draw the outside, and it's going to come inside, draw this, come over here, draw this. So this is now all one single continuous perimeter, which has a much, much higher probability of successfully printing because it doesn't have to stop, retract, move, and extrude. It can extrude this as one big giant perimeter. And when it gets to layer 4, it stops doing that. And now it's printing normally. Ooh, that did not look equitable. Yeah, I think I'm going to increase the infill for that.
Oh, we're getting another.
Go 15%. It only adds 10 minutes. Much better. Yeah, that looks much better. Much, much, much better. That'll print a lot cleaner. Okay. Let's save this as flashlight head. Okay. Now we need to, no, don't do that. And I just deleted that. Okay. That, add this. This does need to be inverted. There we go. And we will do this with no top and bottom layers.
Hey, did you say I get battle?
Oh, I don't need 4 perimeters, so I gotta change that. This I want to be grid. 20%.
I have to look again because I didn't.
25. That's more like it. I like that.
Hard enough. In the battle. Where I had. Okay. Um,
Yeah, I can live with that.
the bruise got big and hang on a second.
Hold on.
I felt
Yeah, that's fine. That should work. I would like more infill there, though. I mean, that's not horrible. Yeah. Probably next week. We'll hopefully I'll have all the parts necessary to put it together next week. I keep forgetting Tinkercad has different commands for moving things around. Yeah, see, I don't like that. I don't like that one bit. I mean, I think it'll work.
Oh, when you are automatically.
I'm gonna go for it. I mean, it'll be a little sloppy, but it'll be you won't be able to see it. It'll be on the inside.
I think fabric.
I think it's good enough. Flashlight body. Yeah, I think that'll work. So there's my G code. I'll do the first one in PLA. Eventually, I'd want to do it in ASA or ABS to make sure it can handle heat. So, for example, if you toss it in your car, you wouldn't have to worry about it melting. Although, for something with this much structure, PETG would probably be enough too. I mean, I bet this would work with PETG. But I'll do it out of PLA. I think 95% of the time PLA will be fine. You know, unless you toss it up on your dashboard, I don't think it'll get hot enough to bother it. Yeah, I think that'll work. That's not what I wanted to do. Why would you do all three? Dumbass. Oh, that wasn't the G code. There it is. There's the G code. Oh, I changed something. Now it's telling me 11 hours. Why would that change? Okay. I'm okay with that. There's the head. And there's the retention plate. Yeah, that looks strong enough. Oh, that only take 13 minutes. That'll be a fast one. I'll probably print the head and the retention plate first, because I can print them in a few hours. And this way I can play around with fit and finish, you know, make sure it fits right. Okay. I'm happy with that. So we will try it. Thursday and Friday, the rest of the parts should be in. I've actually got enough switches here. Although they'll be in tomorrow. The wires will be in tomorrow. The only thing I don't have is a charge controller, but we can work around that. We don't need that right away. Okay. Okay. We won't be using the reflectors because I want a big, broad area light. I would like to integrate a magnet into this, a nice beefy magnet, so I could stick it to something metal. So at some point, I'll probably integrate a magnet into the bottom. Slap a big hole right there for a magnet. What's available for that? What I really, can I take that off? Like, if I can get rid of that. Like, I wonder, can I remove that stub sticking out of there? I mean, I could design it to accommodate the stub, but I'd rather just get rid of the stub. Although, if I design it with the stub in place, I could then put a screw through it. A nut and bolt like this. That might actually be better. That would be pretty ideal right there. And I should have some of these lying around. Although I think I used them on the car. Here's some. Oh, here's one. How big is this one? Because if I can use one I already have, all the better. Oh, yeah. Just grab that. Why can't I see that? That black edge is like invisible. So that is 32, 33 millimeter. Yeah, about 33 millimeter. Can I fit a 33 millimeter? Oh, yeah. Oh, easy. More than enough room. Okay, let's hollow this out. Oh, I got tons of room. Okay. Let's see, how thick is this? It is 9 millimeters. Let's call it 10 millimeters. Okay. Did I bring that down -1? Now it's -1. Now I can make it 11 tall. Okay. How big is the... We should add taller screw, but I can work with that. And I don't have to buy anything. I already got it. Lick my balls.
Back again.
Seven millimeter hole. So Control D. Let's make you a little taller. And let's make you 7 by 7. Oof, strong magnet. I like playing with magnets. Center, center. Okay. Now, how? Wow, that's strong. Holy crap.
What you do now?
I didn't want to let go. Okay. We are 14 millimeter. About 14. So that means we need at least 7? 6. 1, 2, 3, 4, 5, 6. Okay. Control D. Now I need to go all the way up into here. And this one needs to be this wide. Let's call it 17 millimeters. Jesus. This magnet really grabs. There we go. Now let's get rid of this for a moment. Let's grab all this, line it up after fixing that into place. Let's join these, turn them into a hole. All right, there's the cavity for the magnet. There's the cavity for the shaft. There's the cavity for the nut to go down inside to thread it together. Heck yes, we're doing this. Let's see. Solid again. Oh, heck yes. That looks awesome. Yeah, definitely doing that. And I dropped the washer and the lock washer and the nuts down inside there, thread it together. And now this will have a rubber coated magnet. Rubber coated is so like if I attach it to my car, it doesn't scratch the paint. Yes, 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 yes. That is perfect. Definitely designing it for that. Oh, wait a minute. We have to put the cut. That'll work right there. .72. That is 246. 4812. That is 0.72. Then come on. 0.01. Let's center these. Seriously, you got to put it over here. You're gonna mess with me on purpose. And then join those. Now I have a cut joining that, although I will need a little bit of support. That's the only thing that's going to suck, because I'm going to need a little bit of support in here. Because that's not going to work without support. Unless I could probably design breakaway support in there, but I think it'd be easier just to use support. If the shaft was a little taller, I could make this a cone. That's the only downside, is that's going to mandate support. Yeah. .8 millimeter layer height. You can't print a 2.8 millimeter layer height unless you have like a 6 millimeter nozzle. Did you mean 0.28 millimeter? If you want to print a 6-foot tall robot, you could do it in less than a week. You just need a 1.2 millimeter nozzle. Then you can start printing fat layers. I could print a 17-inch hollow component, 17 inches tall, roughly. Yeah, about 17 inches tall. In less than 24 hours. Which means I could print something 6 foot tall in 4 days. Okay, so this is going to require some level of support. I don't see any way of getting around that and still having enough meat to be able to, if I tried to print a cone, there wouldn't be enough meat here. And this might break out if I tried to print that without support. So this is just I'm just gonna have to print this with support. That little bit's gonna require support. That's annoying as hell, but what are you going to do? Actually, there is a way I could do it without support. Oh, no, 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 no. We're doing, no, no, no. We're going to fix this. Yeah, 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 yeah. Oh, yeah. Watch this. Slap a cylinder there. .24. Yeah. Fuck you, support. I'm just that good. There you go. Now I blocked my hole with one layer. And then all I gotta do is take my deburring tool, stick it through that layer, and go zip, gone. I really, really hate support. Like, I hate support so much. I did not ask you to do that. Why would you do that? That should be this one. Oh, yeah, that'll work. There, they're all connected. Now watch this. Lick my balls is back.
Right.
Bye-bye. Yeah, just get a large format printer and put a 1.2 millimeter nozzle on there. You're only going to print at 30 millimeters per second, but you're going to drop so much plastic per circuit that your actual volumetric speed is going to skyrocket. Watch this. See? Boom. Now it's a bridging operation. What I really need to do is to make that a single layer. I need to make this one big single layer. All right, this is at layer 43. I need to make 43 a solid diaphragm. Let's see. Tools, variable settings. What is that? 43 times 0.24. That's 10.32 millimeters. Yeah, this will absolutely work. You'll wait until you see this. You'll get a kick out of this. Split the process. And this will also allow me to increase the amount of infill for those bottom layers as well. Nope, that's the wrong location for that. Okay. So what I want is a... Where did I do that? Where did I do that? Additions? Nope. Infill. Yeah. Include solid diaphragm every 43 layers. Why is it doing it separate? Why is it doing that? It should not be doing that. It should be doing it as one solid piece all the way across. But it's doing it as two separate. Oh, that is so annoying. See, now all I gotta do is bore out that one layer, but that should not be doing that. That should be one solid layer. I bet you that bridging command is kicking into play. No, use fixed bridging infills turned off. What happens if I do this? Nope, it's still doing it as separate. Why is it doing that? I mean, I think it'll still work, but it'll work better if it went straight across this entire hole without stopping. Why is it doing it as two separate things? That is a solid layer. I want this green to go straight across. And it should do that. I can't do a heel because that'll fill in these holes too. And I don't want to fill in those holes. I mean, I think this will still work just fine, but it's not doing what it's supposed to do. I can also increase the number of layers to 4 bottom layers, which will help with that a little bit. There. That gets me my sacrificial layer plus 3 layers on top. So the structural integrity will be good. But still, it should not be doing that. And worse, the overlap is wrong. I want this infill to overlap this. Instead, it's bringing this infill right to the edge so that this bridge has almost nothing holding it up. It should not be doing this. These should be lined up. It should be seeing this as one solid layer. Why is it changing direction? Sometimes the layers do a weird thing. Let's make this 42. Let's see what it does. Nope, it's still... It's a solid layer. It's a solid 0.24 millimeter thick layer. There is no reason for it to be doing that, except Simplify 3D is trying to be intelligent. I think I know why it's doing it. I just don't know how to stop it. I think this here is doing it. Let's see what happens if I do that. Okay, let's change that to 45. Okay, now we're going the same direction, so I'm on the right track. That's what's doing it. But see, this should not be two separate prints. This should be one solid diaphragm all the way across. I mean, obviously, if I turn on heel here, see, it's supposed to be straight across like that. But as you can see, it gets rid of these holes over here when I do that. And obviously, I don't want that. I need those holes. See, those holes start off there, and the heel command gets rid. But this is what it should look like. It should be solid all the way across. This is doing something. No, S3D has not been updated. Yeah, I know what it's doing. What if I... What if I tried to go outside of bounds? Got it. Fuck you, bastard! Yeah, I tricked your stupid ass settings. Got it. That's what you get for messing with me. No, it's split again. What the hell?
It's like I got you now.
Why did it change again? Oh, do I have to change that setting in both? Flashlight body. It's look at this. I print them together, it does this. But if I print just this, it does it right. That's what it should look like. One solid, continuous sheet going across. Why does it break when I print them together? Maybe if I do them sequentially. No, it breaks it again. Why does it break it? Is there something else I didn't change? Well, I changed that to 45. I bet you I didn't change it on the other one. Maybe the settings have to... No, see, it's still not doing it. It's printing this way, and it's printing this way. There it goes. I was on the wrong layer. Okay, I was on the wrong layer. That's what I want right there. Okay. That is some weird settings. So now when it's done printing this, instead of printing support here, it's just going to bridge a single layer of plastic straight across the whole thing as if it's one solid layer. Now that layer is going to be a little goofy, but that's okay because all I'm going to do is take my tool and punch this out. And now I can print this without support. Okay. See, the thing is, one of the benefits of Simplify 3D is it simplifies things for you. It figures out how to do things right. The problem is when you start using tricks to trick the slicer into doing things, you start to bump into those simplify algorithms. And that's what we were doing. We were bumping into the solid diaphragm intelligent settings and the bridging intelligent settings. And those two were conflicting. There. Now all I gotta do is punch out that little tiny bit of plastic right there, and this will fit right in there. And now I'll be able to stick that magnet in the bottom of there. Good, 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 good. I like this. I like it. Yep, I can make that work. I can live with that. I've done this before with the solid diaphragm. It works very well. It probably would have worked to let it do it the weird way it wanted to do it, but this should work better. Since now, instead of bridging from here to here, and there's a chance that that bridge will disconnect on either end, well, now it can't disconnect because it's actually going from over here across all the infill, across the perimeters, and then without stopping, without retracting, straight across this gap all the way over to here. So this inside here should be a whole lot cleaner. And even if it's not, it doesn't matter because all it has to do is successfully put enough plastic here to be able to then print on top of it so that we can stick that magnet in there. Because once you stick the magnet in there, you're never going to see that ever again. Awesome, awesome, awesome. I can live with that. That's good. All right, save it. Flashlight body. And it moved it, of course. Why does Windows do that? Why would you move it back over here because I overwrote the file? Why not just leave it where I put it? Do as you're told. Did I get my connecting lines? Yes, I got my connecting lines. But this will all print as one big single perimeter. Okay. Yep, that'll work. Awesome. I'm gonna start printing this today. I got some nice green filament I want to use. Although I got some other stuff too. But I got a roll of green back there. I'll probably use that. Still want to try to figure out how to use this. I'm gonna have to take some high-res pictures, microscope, really take a look at this. Why does it feel like it's getting cold in here?
Kids, I felt that too. Like, what the heck?
Like it feels like it cooled down even though the heat's running.
I could feel it all over here in the kitchen.
It's 57 degrees outside, so it's getting warmer outside. I don't know. Well, we are trying to make it 20 degrees warmer in here, but still, I wonder why it's struggling so much. Awesome, that's gonna work. These I'm gonna have a lot of uses for these. I'm blown away by how small these are. I did not expect them to be so small. I also didn't expect these all to use the same switches. I'm kind of annoyed now. I ordered 100 of these switches and I don't need them because every one of these lights comes with one of these switches. Every flashlight comes with one, and every push light comes with one, which means I'm actually going to grow my collection of switches because I have to buy 2 of these flashlights and 2 of these puck lights to get all the emitters that I need. I only need 3 switches, but I'm going to get 4 switches for each set of lights I buy. So I actually didn't need to buy those switches. That's not a very bright flashlight, but it works, especially if you have 2 of them. So now I just got to find the USB-C charge controller for the lithium iron phosphate battery. Hey, do it! It's going to work. I just realized you can make a multicolor version of this. You can swap parts. So, for example, I could take the blue cap off and put the black cap on. And I should have the top housing here somewhere. There it is. There we go. Come on. There. Now it's black and blue. So I can get 3 different colors on here if I want to. No, he hasn't popped up again yet. Yeah, I'm kind of excited about this. I mean, theoretically, it should be the last flashlight I'll ever need to make. Oh, they move things? Oh, yeah, now you can do multicolor if you want to. So this flashlight's going to have 2 of these in it, and it's going to have 4 of these in it, 2 on each side. So I'll be able to turn on a wide beam light or 2 focused lights. And I'll also be able to turn on all 4 wide beam lights and set the light down and create an area light to light up a whole area. And with a 10 amp hour battery, we're going to use 2170 lithium iron phosphate 5 amp hour batteries. And we're going to have 2 of them, so that's going to be 10 amp hours of power. Which should run one of these for 20 or 30 hours. Actually, it'll probably run these days. But I'm hoping to get my objective would be nice to get 24 hours with all 4 of the little lights on. And these should undervolt a little bit. 3 alkaline batteries should produce just a tiny bit more voltage than the lithium iron phosphate. The lithium iron phosphate's 3.7 volts. It's probably going to drop to 3.6 or so under load. While the alkalines are 4.5 volts, but they very rapidly drop to 1.1, 1.2 volts when you put them under load, which is 3.6 volts. So it should be just about the same. I did find out you can't, batteries will, they'll self-balance. You just have to make sure the voltage is pretty close before you connect them in parallel, because the actual load when they self-balance can be quite high. Like he had a 0.1 volt difference between the batteries, and the one battery pushed 500 milliamps into the other battery, which was a pretty big load. Um, so I just got to make sure both batteries are pretty close to the same voltage, and then once I connect them in parallel, the stronger battery will charge the weaker battery until they're equal, and then I can charge and discharge them with the single 1S controller, and it'll be fine. Um, I haven't ordered the USB-C controller yet because I have one. I know I have one. I bought one. I just gotta find it. In the meantime, I can just use any lithium charger to get it, just charge it up like halfway to to avoid overcharging until I get, I can buy a bulk of USB-C lithium BMS boards, but it's like $10 for like 15 of them. They're less than $1 a piece. They're so cheap, it's ridiculous. But they're lithium ion, and I don't want to use lithium ion. I want to use lithium iron phosphate because lithium ion is good for 2 to 4 years before the batteries start to become a problem. While the lithium iron phosphate batteries will last longer than I will. It'll be a lifetime battery, and that's kind of the point. Dollar stores. So I'm going to use two of these. So two of these flashlights. I took the unit out. Here's the reflector and the LED bulb, and that's gonna be two of those in the head of the flashlight. And then I got those little, those little puck lights, the little, click click puck lights. We're gonna put four of them on the side, so it's gonna be like this. So this is where the switches are gonna go. That will be these switches right here. There's gonna be three switches. One switch for the two headlamps, the flashlights, and then a switch each for the two LEDs on the side and two LEDs on the side. Um, the 2170 batteries will go inside here. There's enough room for three. We're just going to use two, and then we're also going to put a magnet in the bottom of the flashlight, with a rubber coated magnet, so that doesn't damage like paint and stuff like that. And that's going to go in the bottom here. So these are the power distribution conduits. So I'll be able to take the power from the charging board. It'll come out into that channel and that channel right here. These are 10 millimeter wide, so big enough for me to get a set of, stick through. I can use something like a straw to shove the wires through, and that'll get the wires up to the switches, which are connected to these channels, and also into the battery cavity. And you can see here, there's channels in here. So if I depress the switch, I am switched to this. Yeah, you guys can see. So these channels will allow me to pre-wire all these switches and then slide them into those channels and then secure them into place. Then the other two flashlight reflectors will fit into here, and then this plate here will screw down and hold them in place. And they will all have JST plugs. So these will all be unpluggable, swappable, upgradable. The idea is for this flashlight to effectively last forever and to also be serviceable. So if I break something or want to change something or an LED goes bad, I can service it by being able to disassemble it, change out components, whatever I want to do. The idea is to not be a throwaway part. And then right here is going to be a little charger board that'll have a USB-C plug on it, and that's how you'll charge up the batteries with a USB-C cable. So you just get your standard USB-C cable, plug it in, and the batteries will recharge. So the BMS and USB socket will go here. These channels here are simply to make it easier for me to wire this whole thing up. The batteries will go in here. The nut to hold the magnet will be there. This is the conduits here to run power to these little LEDs. That'll be on the side of the unit. Theoretically, this should totally be solar chargeable. I don't know how to do the electronics for that, but in theory, there's no reason it shouldn't be. Get rid of the get rid of 2 of the LEDs on the side, or make the entire thing a whole lot bigger. But get rid of 2 of the LEDs on the side, and you could put a solar panel on the side here. And you just have to figure out how to wire that solar panel. Either you'd have to send that solar input to the battery input of the USB charge controller. The trick is the USB charge controller has a couple of LEDs on it. Well, the idea here would be you would have your USB cable and you would have your solar battery pack. Okay, so here's your solar battery pack. So this battery pack would sit outside charging, and then, once every couple of weeks, you would plug in your USB-C cable and charge up your phone, charge up your flashlight, whatever, or just use a straight up solar panel, something like this, a big solar panel. But as far as making this directly USB chargeable, can you? Yes. Do I know how to? No. If you can put a sufficient amount of solar panels on here, see, here's the problem. You're gonna have a little circuit board inside of this thing, and that circuit board is going to be connected to the battery, and that circuit board has an IC processor, stuff like that, little chips on it, and it's got LEDs on it. So when you plug in the USB-C cable, it lights up red, and when you're done charging, it changes to blue or green or something like that. The problem is you need to have enough solar panel that it if you don't have enough solar panel, the LED on the charging module, it's rated for 1 amp. No, 2 amps. 2 amps. The LED on the charging module will consume more power than the solar panel, meaning you'll actually deplete the battery. So you would need a Zener diode to prevent power from going backwards, because at night a solar panel will actually draw power from the battery. So you put a Zener diode in there so the power is one way, so that you can't take power away from the system at night. And then you'd also, ideally, you would need a separate charging circuit for the lithium iron phosphate battery. No, it's absolutely invented. I mean, I have solar flashlights this big, so I know. Actually, that would probably be your best bet. Your best bet would be to take the circuit board out of an existing solar power flashlight and design it into this. So you'd have 2 separate independent charging circuits in this. You'd have the USB-C one for convenience, and then you'd have the separate ultra low power version that goes with the solar flashlight. See, the problem with a solar panel on the flashlight body, there's 2 problems. You need voltage and you need amperage. Voltage is no problem. We just need to get to 4 volts. As long as we can get to 4 volts, we're fine. Most of those little solar panels are half a volt, so you need 4 of them. Okay? So, for example, the question is, could I use the solar panels on the little solar lights that you get at Dollar Tree? Could I use those solar panels to do this? I'm not sure. I'll have to measure the amperage that comes out of them. I mean, they can successfully charge a AAA sized battery. So one of them charges a AAA sized battery, so 3 of them should charge a lithium iron phosphate battery. The trick would be, here's the problem. When you charge up a battery like this, these batteries are tolerant to abuse. So if I overcharge or undercharge this battery, it doesn't matter. It's not going to hurt it. It can handle that abuse. This battery, however, the lithium battery inside the device, has very specific requirements. And that necessitates what's called a BMS, or battery management system. That's the circuit board that makes sure the input power is correct, that it does not discharge the battery too far, that it does not charge the battery too far, that it stops charging the battery when it's full. And when a battery gets low, it cuts off power to the battery to prevent the battery from being permanently damaged. That's what the BMS does. This doesn't need a BMS. I can just drain this fucker until it's dead, and it's not going to care. It's still going to take a charge the next day. Okay? If you drain a lithium battery till it's dead, you kill the battery. You destroy it. So you have to have a BMS. And the problem is the power consumption of the BMS. When you're plugging in a 2 amp USB or 1 amp USB source, the power consumptions of the ICs and the LEDs is irrelevant. That red LED is going to consume, 5 milliamps of power. But if that red LED consumes 5 milliamps and the circuit board consumes 5 milliamps and your solar panel is only delivering 11 milliamps, what happens? Or worse, what if your solar panel delivers 9 milliamps, which is enough to activate the charging circuit, but not enough to actually charge anything? So what's powering the LED? Well, the battery's powering the LED. So your device actually discharges now. That's why solar lithium devices either don't last long. Like, for example, I had back before we had Bluetooth stereos in our cars. I had this solar powered Bluetooth speakerphone. It was actually about that big, and on one side was a speaker, and on the other side was a solar panel. And you would stick this thing on your windshield. Now you had a speakerphone in your car that you never had to plug in. It would automatically connect when you got in. The sun kept it charged. Unless you were talking for hours on it, you're not going to deplete the battery before the sun comes back up again. And that was great, right? Every single one I ever got puffed up and exploded. They would puff up until it shattered the shell of the device. Because the solar charging circuit would overcharge the battery, which would cause the battery to puff up and destroy itself. So to properly charge something like this, you would need to have a low power BMS that's designed for solar. And that's the problem. The technology is there, but can we buy it? Can I find it for $2 or $3 on eBay so that I can hook up a couple solar panels and actually have those solar panels charge the battery? I don't know if they work by simply the BMS uses less power than the solar panels, or if they have a capacitor and it charges the capacitor until the capacitor is full, and then the capacitor dumps its power into the yeah, that's what happens. Now, a lot of times what they assume is that you're going to have it in the sun infrequently enough that it will never be fully charged and overcharging. Hey, Richard Cook, doing pretty good. So the trick, it isn't a matter of can we do it. It's a matter of can we find the electronic component. If you can find the electronic component that will allow you to properly charge a lithium iron phosphate battery from a solar panel, then yes, absolutely. You just put you do what I just did here. You would design imprints to hold the solar panels. Like I could probably fit $3 store solar panels on this. But there needs to be an electronic bridge between the solar panels and the batteries, so that electronic bridge is low power enough to be able to effectively use the little bit of power the solar panels generate. Keep in mind, the solar panels aren't going to charge the battery very fast. You're talking about a 10 amp hour battery, and you're charging a 350 milliamp AAA battery. Even assuming you fully charge that battery, you're talking 3 days to generate 1 amp hour of power. So it would take you 30 days to generate enough solar power to fully recharge. No, I'm sorry, we're using 3 panels. So we'd get 1 amp hour per day. So you would need 10 days of full sunlight to fully recharge this from dead. But you know something? In an emergency, it would work. You can say, well, what's the good? What is the good of having a recharge time of 10 days? Well, here, let me give you another example. I want to solar charge my electric car. The only thing stopping me is I can't afford the solar panels. I need $600. If I had $600, I've got a guy in town who's got solar panels for 75 bucks a pop. I could buy 6 of them. And that, because you with solar panels, you need twice whatever you need. So I need 900 watts, which means I need, at least 16 to 1800 watts of solar panels. So I would need 8 solar panels outside on the ground. I would then plug that into a small battery just to act as a buffer, in case a cloud goes over, some shit like that. And I already have the charge controller. I already have the inverter. I already have the battery. The only thing I need is 8 solar panels. Because I need 1.8 kilowatts of solar panels to be able to make sure I can reliably get 900 watts of clean power out of that. And then I could solar charge my electric car. I would never have to plug in my electric car ever again. Now, how long would it take to charge my car off of those solar panels? Well, 900 watts is going to give me about probably 8 kilowatts a day. So it's going to take 3 perfect sunny days to charge the car. If you say, well, what good is 3 days to charge the car? Well, I don't use a full charge every 3 days. You see what I mean? I don't use a full battery's charge every 3 days. I have to charge the car about once a week. Now, if I drive into Albuquerque, yes, it's going to take longer to recharge because I'm going to use more power. But for my day-to-day driving here in town, I don't use a full charge a week. It doesn't matter how slow the charge is, as long as you're putting the power in faster than you're taking it out. And because I work from home, the car just sits outside there all day. I can leave it plugged into the solar panels. The flashlight can do the same thing. You don't have to use a flashlight that often. So if your solar panels are capable of putting 1 amp hour into the flashlight, that's okay as long as you're using less than 1 amp hour per day. So for example, if you're using the flashlight, say 2 hours per night, that's less than an amp hour, which means the solar panels will be able to replace the power you used. So solar could work. But we need to figure out that middleman. We need that circuitry in the middle that can take the solar energy and safely feed it to the battery in a usable way. I have to figure out how to do that. I don't know how to do that. In theory, that is totally possible. Now, the easiest thing to do would be to just buy a dedicated solar panel that does this. And I have one. I have these little solar panels that have a 2 amp hour lithium battery inside of them. And they got a solar panel. And then it has a cable with a micro USB cord on the end. So I can just cut that off and put a USB-C cord on there. Or just buy an adapter. So while during the day, that solar panel charges that lithium battery inside the solar panel, and then when I get back and I have to plug my flashlight in, I just plug the flashlight in. Even if there's not enough sunlight, the energy is stored inside the battery inside the solar panel. It then uses that to recharge the flashlight. No, that's actually not correct. You do not want to fully discharge a lithium ion battery before charging. Um, the lifespan of a lithium battery is based on charge cycles and SOC, or state of charge. So, for example, your typical lithium ion battery, lithium ion battery is rated to 200 to 500 charge cycles to 80% SOC. So if you have a 1 amp hour battery, after 300 charge cycles, you'll have a 0.8 amp hour battery, in theory, if it doesn't die completely. Now, the 2 worst things you can do to a lithium battery are to leave the battery fully discharged or to leave the battery fully charged. Both are bad for them. So you don't want to leave a battery fully discharged, and you don't want to leave a battery fully charged. And well, that's a completely separate issue I'll get to in a second, Paul. I pulled a old black and white Sprint flip phone out of my storage container once. Now this is a black and white Sprint 2G flip phone, which means the battery was at least 11 or 12 years old at the time that I pulled it out of the container. The goddamn thing turned on. It only turned on for a few seconds and the battery died, but it turned on. The batteries 20 years ago were built to a substantially higher quality level than the batteries we buy today. Most of the consumer level batteries we buy today are garbage. They're junk. That's why you see people looking for, Samsung and LG batteries, the high end, high output batteries. And that's why there are so many fakes copying them. Because they know people are looking for them. And it's very hard to tell the fakes from the real ones when you're trying to buy it. But the optimal state of a lithium battery is 40 to 60. Don't go below 40%. Don't go above 60%. If you charge to 60 and discharge to 40, charge to 60, discharge to 40, the battery will last substantially longer. Good for you. You hit the battery lottery. You got lucky. One thing I do on this phone, for example, this phone has an 8,000 milliamp battery in it. So that's a lot of capacity. So I have a little program on here that chimes when I hit 80% charge to remind me to take it off the charger so that I don't charge it all the way to 100%. There's one of the primary reasons that a Nissan Leaf battery does not last nearly as long as a Tesla battery is because of the size of the Tesla battery. Because my car only has a 30 kilowatt hour battery, I have to use the entire battery every time I make a trip. Every time I go into Albuquerque, I have to use the whole charge, which means I'm fully cycling that battery dead to full. And the battery doesn't like that. It degrades faster. While the Tesla has a 250-mile range, which means to Albuquerque and back, I can do that, 5 times before I have to recharge the battery, which means the depth of each charge cycle is a whole lot less. That doesn't even make sense. Charging causes a voltage drop which appears as a dead battery. That doesn't even make any sense. Most chargers don't pay attention to the voltage drop or the voltage in the battery. They wait until it's begun charging for a bit, and then they do their testing to see where it's at. Matter of fact, that's one of the reasons why the original car chargers would murder cell phone batteries. It's because every time you got in the car, you were turning on and off the charger. And if your phone was at full charge already, the charger in your car charger would begin charging the battery, even though it's already full, which means now it's technically overcharging the battery, which damages it. Now, of course, eventually the charger goes, oh, yeah, the battery's full, and it stops charging it. But for that few minutes or few seconds, it's overcharging the battery every time you turn the key. So more modern chargers, not the crap ones you buy off eBay, but more modern chargers began to get more intelligent. So they would actually sample the battery first. We're going to get to that. So the charger would sample the battery, and if the battery was over 90% charged, it would just not charge. This would say, nope, you're already over 90%, which means I can't reliably tell how much power you have, so I'm not going to charge you at all. So that was the high-end, iGo, Verizon, Sprint chargers. Now, eventually, the cell phone manufacturers figured out, okay, we need to stop depending on the charger to have the BMS circuitry in it, and they started putting that circuitry in the phone itself. So now any modern phone you have, it doesn't matter whether the charger turns on and off, because the circuitry inside to intelligently recognize the level of the battery is in the phone now instead of in the charger. In the old days, they would offload that circuitry to the charger, which would make things a little cheaper, make things a little, phones would be a little smaller, crap like that. But now that circuitry is all built into the phone. But in the old days, 25 years ago, that circuitry wasn't built into the phone. It was built into um, the charger itself. Fail-safe circuitry was built into the phone, over discharge protection, stuff like that. But that was last resort fail-safe protection. The actual charger turning on or off was built into the charger, and that became a problem back then. But nowadays, that's all built into this. No. The cell will stop outputting when its fail-safe circuitry kicks in, assuming it has fail-safe circuitry. So if you have, let me show you. So he's talking about something like this. Something like this that might actually be wrapped in the battery itself. So your battery like this would have one of these along the end of it, and it would be wrapped into plastic with it. And if you opened up something like this, so here's a perfect example. So he is talking about this. So here's a naked lithium polymer cell, and there is what's called a fail-safe circuit. Come on. So that circuit there is not the charging circuit for the battery. It's a fail-safe circuit. So the charger is in the device. The device knows when it's too low, when it's too high, when to stop. If that fails for whatever reason, this is your last resort backup. This will cut off power if it goes too high, or cut off the battery if it goes too low. Because there's no such thing as a battery the battery does not ever stop outputting. The battery is dead at what 2 point something volts or 3.1 volts or something like that. 3.1 or 3.2 volts or something like that. Ew, cat, you stink. You can draw that battery down to 2 volts and you'll destroy it. This fail-safe circuitry is designed to prevent you from doing that. This fail-safe circuitry will say, oh, no, we can't go that low, and it'll cut off. That's important when you try to wire something directly to a lithium battery without going through a BMS circuit. The cells that we're using for this flashlight do not have a built-in BMS, which means we can deplete those cells below their minimum level. And once you do that, you destroy them. They become ruined. It can actually damage the cells to do that because they don't have a BMS. That's why we have to install that little circuit board. That little circuit board will sense the battery and go, oh, you're too low, and it'll cut off power going from the battery. So that basically, that circuit board is what turns off the flashlight and keeps you from damaging the battery. But you have to have that little BMS. You have to have that battery management system, or that's not going to work. I could take that circuit board off, and I could wire this battery directly up to a bulb, and it will work just fine. And it will continue providing power below its minimum amount until you destroy it, and then it won't be able to take a charge anymore. So you don't want to do that. You want the BMS circuit in there. Every single one of these you open up. If you open up any one of these batteries in any device, open up the battery in your cell phone, open up the battery in one of these, any of these polymer batteries you open up, once you take off the Kapton tape, you're going to see that little tiny circuit board inside there. And that's what's protecting your battery from being over discharged. I don't really care about what is contrary to common understanding because there really isn't much common understanding. Most people have no idea how these batteries work. They really don't know. They just plug them in and they work, and that's all they understand. I'm talking about scientific knowledge. I'm talking about actual data. And actual data is if you discharge this battery below its minimum voltage, you damage the battery. And there is nothing to stop you from discharging the battery. It will not stop outputting power. It'll output power right down to 0 volts. What stops it is this circuit board. That circuit board is what stops it. But that's a problem. And this is where the quality of the cells come in, because that circuit board takes a little bit of power, which means the battery just sitting there is very slightly discharging. And that's a problem. You don't want the battery to, you can't just stick this battery in the drawer for years and years and expect it to still work. That's going to depend on the quality of that circuit and the quality of the battery itself. Because some batteries have a higher discharge rate, a self-discharge rate. If you don't plug them into a proper BMS, absolutely. A lot of people go for the unprotected cells because they have a little bit more juice. They have a little bit more milliamp hours in them. Because the new 186, this is not an 18650, but the new 18650s, the little chip, the discharge, the last resort over discharge chip is actually right in the end of the battery. It's a little circular chip that sits right on top of the end of the battery. And so, of course, that consumes volume. And if you're consuming volume, you have less capacity. So if you look at a protected battery and an unprotected battery, the unprotected battery will have a larger capacity than the protected battery, because the unprotected battery doesn't have a chip taking up space. But if you don't know what you're doing, it's like little grenades. Lithium-ion batteries can be quite dangerous if mishandled. But what kills a battery is defects, micro defects in the construction of the battery. Nice, 18 amps is a lot of juice. And if you know what you're doing and you plug those into a proper BMS, you're fine. Because the BMS is going to do its job and prevent you from over discharging or overcharging. It's going to control the float of the battery. And that's fine. There's nothing wrong with that, as long as you know what you're doing. We just don't tell newbies to do that because they don't know what they're doing. You say common misconceptions. No, there's no common misconceptions. They're just clueless. They're used to AA batteries. And you start, you hand one of them a battery capable of dumping 18 amps. So you get 4 of those batteries, 5 of those batteries together, and you could dump close to 100 amps. That can mess up your day if you don't know what you're doing. So that's why we suggest, newbies, be careful. Use protected cells. Don't go crazy. If you know what you're doing, great. There's nothing wrong with that. Just got to know what you're doing. That's all. It's like telling people to modify their 3D printers. No, don't modify your 3D printers. Or puncturing it, or crossing wire. Yeah, shorting it. If you put one wire backwards. And then when one battery lights off, it lights off the other batteries. And then, of course, they're, again, because they're ignorant and stupid, they put water on it, which just makes it even more energetic. You can't put lithium out with water. That doesn't work. It just makes it, boom, harder. That's what happened to the Aerotech factory in Nevada. They had all their hazmat permits and shit, so that the reason we require companies to go through all these hoops for hazmat and crap like that is so that when something bad happens, the procedures are in place to deal with it. So when you have barrels of powderized magnesium lying around, that can be exceptionally dangerous if you don't know what you're doing. And a fire started, and the fire department showed up and sprayed the burning powderized magnesium with water. Boom! They blew the place up. And then they tried to blame Aerotech and say it was their fault. Oh, bullshit! Your morons came in with water and sprayed magnesium even after we told them not to. So, ignorance is bliss until it blows your face up. But that's the deal. This battery, I don't actually know what the voltage range is. Let's say it's 3.1 to 3.7 volts. So let's say it's 2.7 to 3.7 volts. I don't know what it actually is. I'd have to look it up. You can draw the battery below 2.7 volts or 0% capacity. The problem is you're going to damage the battery doing it. And another thing, don't stabby batteries. That's a good way to make them go boom. Actually, if you want to have fun, charge up a lithium battery, especially these little bag batteries, okay? And tape a nail to the end of a stick or a hammer. All right? Go out into the middle of a parking lot, 100 foot from anything flammable, and take that hammer with the nail on it and go pop right through the lithium battery, then step back. It's an interesting show. You get to see just how much power is in these little batteries. This is probably what, 800 milliamp? No, this is 1200. This is probably 1200 milliamps. So 1.2 times, what is that? Let's see, 1.2 times 7.2. There's 9 watt hours of battery capacity in this little tiny package. That's a lot. Hey, just hit YouTube. You can watch a dozen of them, 100 of them. People popping batteries on YouTube. Better them to do it than you to do it, because they will basically detonate. They will. You'll either have a rocket thruster or you'll have a grenade. Do you want to be near either one of them? I don't want to be near either one of them. Out when I had that battery pack catch on fire in here, that UPS box, I had both grenades and rocket thrusters. Some of the batteries went and burned through the other batteries, and some of the batteries went pop and launched 20 feet. So you got rocket thrusters or grenades. I'd rather watch somebody else do it on YouTube. I don't want to burn down my house. Now, another reason to use lithium iron phosphate batteries. God damn it. Another reason to use lithium iron phosphate batteries is that they are far less likely to detonate. It's actually very hard to make a lithium iron phosphate battery blow up. They're just a much more stable chemistry, because iron is more stable than cobalt and manganese or whatever else they're using in these batteries. But so why don't we use them everywhere? Well, they are starting to use them everywhere. People are starting to get sick of their devices being dead after 2 or 3 years because the cheap piece of shit Chinese batteries that they put in them last 2 or 3 years and then they're dead. Because we don't use Japanese or Korean cells anymore. Why do you think your Samsung and your iPhone battery lasts a lot longer than your other party batteries? Well, because Samsung is putting quality cells into the phone, so they last a bit longer. Unless they blow up on you, that happens too. But lithium iron phosphate has some downsides. There's no such thing as high quality or low quality Chinese products. There's no such thing. That's a myth. They call it Chinesium or Chinese crap. A good buy price is the current market supports about $75 to $85 for 250 watts. That's about what the used panels are going for. And everybody charges exactly the same price. I don't care what solar panel it is. You divide the price by the watts, and they're all the same. So they're all looking it up in advance and saying, okay, that's the market prices. I'm not selling for less. So it's a good deal. A normal deal is $100 for a 250 watt panel. A good deal is 75 watts for a 250 watt panel. So that market seems to be fixed. where it's very difficult to get a good deal better than that. China does not make Chinese garbage, and China does not make ultra high quality products. China makes whatever the hell you pay them to make. So the reason there's a lot of Chinese crap in the US market is because American companies ask them to make Chinese crap. And if you want them to make you crap, they'll make you crap. And if you want them to make you high quality products, they'll make you high quality products. I mean, some of the best products in the US come from China, and some of the worst products in the US come from China. It's just a matter of what are you willing to pay for. If you're willing to pay a more reputable Chinese company a higher price, they will make you a higher quality product. There's no such thing as a 9,000 milliamp ultrafire battery. They don't exist. Those are fake. The highest capacity you can get an 18650 cell is about 34 to 3600 milliamps. Unless you go unprotected, then you get a couple hundred milliamps more. But 9,000 milliamp hour batteries don't exist. They're all fake, every one of them. Every one of them that says 9,000 milliamps is fake. Most of the ones that say 2,000 milliamps are fake. You'll buy the 2400 milliamp battery, and then when you test it, it's 900 milliamps. Because again, they make the fake ones that they call 9,000, and then they make the fake ones that they call 2,000 because they can get them for half the price. A good way of determining the quality of your cell is to weigh it. Weigh the battery. Weigh a good quality LG or Samsung 2400 milliamp cell, or 3400 milliamp. What is it? 24 or 34? Is it 3400? Yeah, I think 3400 is the highest you can get. 3000 or 3400. That's the highest. Okay. These batteries have what's called a power density. You have this much cubic volume of space. You can fit that much milliamp hour of power into that cubic volume of space. And lithium ion has a limit. There's a limit to how many milliamps you can fit inside that casing. And so when you have a battery manufacturer telling you our battery is 3 times the highest the technology can theoretically support, well, it's fake. And a good way of testing that is to weigh them. The heavier the battery, the higher its capacity, because the more layers and the higher the density of material inside the battery. Now, the problem is finding a reputable seller, because there are so god-awful many fakes out there. God almighty, there's so many fakes out there. But yeah, anything above 3,000 milliamps, begin questioning. And also, even that 2 or 3,000 milliamp cell, if the price seems too good to be true, it is. It's fake. Okay? If someone's trying to sell you a 3,000 milliamp, 18 amp Samsung cell for $4, it's fake. Because you can't buy one for $4. You can't. It's like 11 or 12 bucks a cell. Now, I mean, if you're buying them in bulk from the manufacturer, that's different. You'll get them cheaper. But buying them on Amazon or eBay, unless you're buying used cells, which is totally fine. Usually if the price is less than 11 bucks a cell, they're fake. At least you should be assuming they're fake. So if you're trying to sell me a 3,000 milliamp Samsung cell for $6, I consider that making an extraordinary claim. And what do we say about extraordinary claims? They require extraordinary proof. You're going to have to prove to me those cells are real, because I don't think they are. It's like million lumen flashlights. Yeah, they're like 200 lumens. But it looks good to say million lumen on the box. But now, why don't I would like to see phones and other consumer electronics start using lithium iron phosphate batteries? Why don't they? Well, they're not as common. Even though lithium iron phosphate is actually an older technology. The power density of lithium iron phosphate is less than the power density of lithium ion. So if you can fit, 1,000 milliamps of lithium ion in this package, you might only fit 800 milliamps of lithium iron phosphate in this package, which means you either have to accept less capacity or you have to make the battery bigger. You have to accept that your product will have to be bigger. I think phones have enough space that people would be willing to accept lower capacity if it meant longer life. I would be willing to accept a 20% cut in capacity if it meant my phone would last 20 years instead of 3 years. Now, for something like earbuds, well, that might not work because the battery that's in there is already so tiny that a 20% cut in capacity might be more than they're willing to accept. Especially, it might even be worse when you make it that small. So there are some applications where lithium ion just makes sense. Also, it's much more expensive to make high power lithium ion phosphate batteries than it is to make high power lithium ion batteries. So to make that equivalent, 3,000 milliamp, 18 amp Samsung cell using lithium iron phosphate, the battery might be twice the size and twice the cost, if it's even possible. So, your RC car and your RC airplane flyers, they're probably going to be okay with having to replace their batteries every few years because they need the power density and the lower mass of lithium ion batteries. But your car, for example, that makes no sense. I mean, they should only be using lithium iron phosphate batteries in cars. I'd still have 110 miles range if they used lithium iron phosphate in my car versus the 60 miles that I can actually go. So that's the difference. Lithium iron phosphate is less volatile, but it also has lower overall power output and a lower power density, which means the batteries have to be bigger in order to hold the same amount of power. Which is why you use lithium iron phosphate for your house, because size doesn't matter when it's your house. Who cares if the battery is 3 inches bigger when you have a 4-foot long battery bank powering your house? It doesn't matter. But in your phone or in your flashlight, that size difference might matter. That's one of the reasons why I'm designing this flashlight to use lithium iron phosphate, is because I don't ever want to have to replace the battery. I want the battery to be very long lived. And lithium iron phosphate should last a whole hell of a lot longer. They're also more tolerant to abuse. Oh, what's that? But is it lithium iron phosphate? I notice it's actually hard to find lifey stuff. Most of it is lithium ion. You see, that's lithium ion. So that would work for lithium ion batteries, but it won't work for lithium iron phosphate battery. Yeah, lipo. How about LIFEPO4 solar? See what comes up. And all the big batteries come up. How about if I add BMS? No, just big batteries come up. But yeah, in theory, that's what you need. You need a little chip like that that's designed to work with solar, because it'll be designed to handle the variable input that you get from a solar panel and the low level of power you get from a solar panel. I don't see anything here. How about we search eBay? eBay's probably going to give me a better hit. And then I can sort cheapest first, which will get me all the little circuits. No, when I do solar BMS, The cheapest thing that comes up is PCB, 8S 24 volt. It's the right thing, but it's for the big batteries, not for the little batteries. Solar circuit. Search. This is for the bigger ones. So this is for 4.5 to 28 volt DC. So this is for like solar streetlights. It does do lithium iron phosphate. How does it differentiate? It says 1 to 4S. That's a low enough power level, but what's the quiescent draw of this device? And how do you separate? Because lithium iron phosphate and lithium iron are not the same. They do not charge to the same amount. So there has to be a way for you to tell this circuit to charge lithium iron phosphate. This is also designed to turn on at night and turn off during the day, which is a problem because that means when the solar panel is covered, this is going to turn on, which means it might be drawing power. That's a problem. It'll discharge your battery. But this is really made for the bigger solar panels and the bigger batteries. This is not made for these little tiny cells. But the problem is that's in the IC. So that little there should be an IC in here somewhere that's going to tell it to do that. And if you take out the IC, you're probably taking out the controller as well. You just got to be careful. A lot of the times they just straight up lie. They'll say, "Oh yeah, this works," and no, it doesn't. How big is our flashlight? 100 millimeters. Okay. So we should be able to fit like a 1.5 watt panel on there. That's why the best thing is just to go through the USB-C controller. And this has no overcurrent protection. And there's the big problem with solar panels. If you're already fully charged and you keep trickling that power into it, you kill the battery. And this circuit board has no overcurrent protection. You can get around some of that using a blocking diode. Actually, I have something like that I'm putting in the car. I have this 1.5 kilowatt hour battery box. I'm actually going to put that in the car so I can charge the car up like when I go to a store. I mean, I can only get like 6 miles of range from that battery, but hey, that's 6 more miles than I had before, right? So here's 50 millimeter. There we go. 160 milliamp, 50 by 50. You could probably get two of these on there, which would be 300 milliamps. That'd be enough to charge it. Yeah, they're expensive. Yeah, you're looking at about $900 for 300 amp hours. So about 350 for 100 amp hours. You would definitely want to go with the 300 amp hour. $900, and that'll give you 2.5 kilowatt hours of power, which would be enough to charge the car to trickle charge for 2.5 hours, roughly. Call it 2 hours, which would be enough to put about 11 or 12 miles back into the car. So in theory, it wouldn't be hard to modify this flashlight to contain two of those solar panels right there. I don't like encapsulated solar panels, but they would work. And that would give you, 300 milliamps of charging capacity. Um, Even better would be to embed those two solar panels into it and have two more solar panels that fold over top of it. And then when you want to charge it, you unfold the solar panels. Now you have 600 milliamps of capacity, and that should be enough to use the existing charge controller. You just wire them directly to the existing charge controller, and 600 milliamps is definitely enough to overcome the LED power draw, and that would positively charge it. Probably two of them would as well. I'm betting two of those 300 milliamps. I'm betting that would be enough. The flashlight would just have to be a little bit bigger. I'll show you what I'm talking about. These are the wrong ones, but it's good enough for me to show you what I'm talking about. So you see here, um, you have Type C input right there. Oh, you can't see what I'm looking at. Hang on. So there's your Type C input, and then you also have this positive and negative input. And then up here, your battery would connect, and then your output would connect here. And if you discharge too much, the IC would disconnect the negative output. So cut off the battery. Yeah, I wish I could afford that. That would be 7.5 kilowatt hours of capacity. That'd be nice. Oh, the things I could do with that. But so what you do is this would be your USB-C input, and then your solar panel would just connect to these two parts here. And as long as you had sufficient solar power to light up these LEDs and run this IC and still have power left over, then that would be enough. This is your 5-volt input on the side here. So if you connected two of these solar panels up to it, that should be enough to overcome that and allow you to solar charge this with the existing protection in place. What are these? These are 30 milliamps each, so 53 by 30. And I could probably fit I could fit 4 of them if we made this bigger. Basically, we would intentionally make this flashlight body a little bit bigger in order to accommodate solar panels. And I would use these 50 by 50. So make the body an extra. Actually, that is big enough. You could fit 2 of those. Better would be to fit 3. How wide are we? We are 98. So if I enlarge this body a little bit, I can't really do this without making some other changes. But if I made this body that big, you could put 4 of those on here. And having 4 of those on here would give you theoretically 600 milliamps of input power. And then you could put 4 of these cells on that flashlight. That would work. That would be more than enough power to actually effectively charge this thing. And in theory, you could charge it in 1 day, fully. You'd be better off non-encapsulated solar panels if you can get them. Because the problem with the encapsulated solar panels, they yellow over time. So 50 by 50. Those are only 100. Those are a quarter-watt. That's a quarter-watt. Do they have non-encapsulated solar panels? See, I want the non-epoxy ones. That would work. 80 by 50, 210 milliamps. That's only 2 volts. That's why. But you put 3 of them on there, then you'd have 6 volts. Here's a 1-watt panel, 90 by 90. That would fit. You could put this single 1-watt panel on there. It's only 2 volts. Never mind. Need 5 volts. This one's already got pigtails. That's nice. 2 volts. You don't want to use that. You don't have any small non-epoxy panels? Oh, here's some naked panels. Oof. Half a volt. You'd need 10 of them to do anything. That's like no power coming out of there. Get 100 of them though. 2 by 2 inches is 50 by 50. Here we go. 2.8 watt. Now, part of why they encapsulate them is because, well, to be fair, they are awfully delicate. Hey, Joe. Yeah, I'm going to stand by that original one. The 5-volt 160 milliamp is your best bet. Oh, these are only 2 volt. That's why the amperage is so high. They're only 2 volt. You really need 5 volts. So you need these. So that means I could put 6 of these on there. That's 180 milliamps. You'd have to use 6 of these. And that in max light conditions, that would get you 180 milliamps, which should be enough in theory. if you mounted 6 of these in parallel. We could design a separate one to use these. I'll save these. I can't afford to buy them now, but I'll save them for later. I'd want to use all 10. I'd want to try to design one to use all 10, because then you'd get 300 milliamps, which means you'd get 1 amp hour every 3 hours, which means you should be able to put 3 amp hours of power into the battery per day. If you live in a sunny place like I do, you'd be able to get 3 amp hours of power per day, which means you'd fully recharge our 10 amp hour battery in 3 days, which is really good because you're unlikely to deplete it fully in 3 days, which means you'll be able to stay ahead of the charge curve. But theoretically, that's what you're looking at right there. At that point, it might be worth just designing for one of these. Just make the flashlight a little bit bigger. We'd have to make it 30 millimeters bigger. We'd have to make it 130 millimeters. And then make the body about 200 millimeters tall. But then just design it to accept one of these. And that'll give you 500 milliamp hour per day, or 1 amp hour every 2 hours. So 5 amp hours per day, which would be ideal. And if you were smart, you could put a JST plug in the bottom of the unit to allow you to plug in a second solar panel, and then you'd really get some kick-ass output from that. So while you're away, you charge up with the one panel, but when you're at base camp, you plug in the second panel, and now you double speed charge. And at that point, you'd probably go with 4 batteries inside the flashlight. So now you have 20 amps of power inside the flashlight. At that point, you can now use that as a charging bank to charge up other things. So charge up your cell phone, charge up your earbuds, charge up pretty much anything with 20 amp hours of power, depending on what the output limit is. And then at that point, one of these in the body, trickle charge, and then plug in 3 or 4 of them, daisy chain them in parallel to boost up your charging speed. And you could charge at 2 amp hours, since the little circuit board will handle 2 amps. Yeah, that would work. But it would be a different flashlight. It wouldn't be the same thing. At that point, you'd be more of an area work light kind of deal. Have 4 of these bad boys on a half octagonal face. 4 of them at an angle arrayed to give you a nice broad area of light. Yeah, that would work. We could design one for that next. The hell? Can't fly. Yeah, that wouldn't be that hard. How thick is it? No dimensions. This is from All Powers? Oh, yeah, it is. It's a 2-watt panel. That's pretty cool. with a built-in USB port. There's a 6-watt panel. And this was designed to be daisy-chained. I mean, a 12-watt panel will allow you to charge at full power. Save that one too. And that's only $12 a panel. And those are polycarbonate coated, not epoxy coated. Much better quality. Oh, yeah. Sure they do. What do you mean they don't generate anything? That doesn't even make sense. Of course they generate. What do you think happens when I plug a USB cable into this? What do you think your gas generator does? It just stores power too. You're just storing it in gasoline instead of storing it in batteries. That's the only difference. They're both chemical storage mediums. Gasoline is not a source of power. Gasoline is a storage medium. It's no different than batteries, except I can refill my batteries from the sun. You can't refill your gasoline generator from the sun. There you go. Actually, good generators go pitter patter, pitter patter, pitter patter. The room generators is how the mob finds out you have a generator. Those Honda, the Honda EUI generators, the 2,000-watt ones, 2,500-watt ones, the super quiet ones. You can stand right next to them. Those are awesome. Good generators. But yeah, a solar generator is the correct word for it. You know, that's a good way of describing it. I mean, I don't want to pick it up. It's like 45 pounds. But this thing here holds 1.5 kilowatt hours of power and has a 2,400-watt inverter, which means it can power my microwave. It can power my pressure washer. It can power a drill. It can power a saw. It can power a refrigerator. It can power my stove. This thing can power with 2,400 watts. It can power just about everything. It has 20 amp outlets. It's got a 30 amp RV outlet on it. It's got PD 100 watt USB ports, 10 amp 12 volt ports. And I can plug in 800 watts of solar panels into it. Wow. How much did you get that for? Did you get it for a steal? I bet. Yeah, that's a nice rig. Oh, that hurts. Oh, that's painful. Oh, that's evil. Can't get deals like that around here. Nope. Oh, I have Craigslist obviously saved. Although Craigslist is not very popular around here. Um, um oh, I know. I was about to say 4 or 5 grand for that. Um, so I have, my links for Craigslist here. And you can see the difference here. Let's go to free. Now, let's go to I made the mistake of going to Craigslist Philadelphia. And oh, wait until you see the things you can get. Here's a Sharp Aquos TV. I bet you it works. Ooh, here's some metal grating. That's wonderful. I can do things with that. Some of the things that are in here. Look at this. Sheets of particle board, 3/4 inch particle boards for free. Nice door. It's an old door, but that's a nice door. Wow. Metal closet cabinet. I would snatch up every single one of these I can get my hands on. You can't touch these for less than 50 to $100 here. In Pennsylvania, it's free. There's a fan for free, a mirror for free. Look at this. Look at this. Look at this. KitchenAid under counter ice maker works. Look at that. Oh, that is so nice. That's an expense. That's an old unit, but that's an expensive unit right there. Free. Freaking free. This is one of the nice things about living near Philly. Wooden steps. They're $100 a set here because everybody needs them for their mobile homes. Free. There's a metal cage. Free. Look, an AV cart. Oh, I'll take every one of these I can get my hands on. It's a freaking AV cart. A metal AV cart. Free. Here's an LG electric dryer. Free. There's a corner desk with cubicle walls. Free. Oh my God, the stuff you can get for free. Look at this. That's for scrap. There was this beautiful big. I'm on Twitter. But yeah, go ahead and email me. 3dprinting@nurse.com. Free pieces of granite, free tabletops and desks, free baker's cabinets. You know, they're $30 a pop here. They're free. Look at this beautiful curio, large china cabinet. That's $200 here, free. The things you can get for free. Pianos all day long for free. Roll top desks, free. All this office furniture, free. Oh my God. Another shelving unit, free. Free firewood. Beautiful set of chairs, free. I guess the granite is gone. There was a beautiful piece of granite, like 6 foot by 4 foot piece of granite for free. Oh my God, what I could do with that. Free trampolines. Free cabinets and countertop. More free pianos. Look at this. Look at this dining room set. Oh, Jesus. The stuff that you can get for free in a high density place like like Philadelphia. Those beautiful corner curio. None of this would be free here if you could find it at all. Just it's a poorer area, people are poor, so that's just the way it is. 4 19-inch monitors. Another metal cabinet. For him, it's scrap metal. Out here, that'd be $50. Oh man. And now let's see what's for free in Albuquerque. First of all, there's 1 page of stuff. Well, there's 30 pages of stuff in Philadelphia. Here we have a free. It's actually unusual for a free used chainsaw to be available. I guarantee you that'll be gone within an hour. Here's a queen bed frame. Here's some free garbage rugs. Here's a probably doesn't work electric weed whacker. A mattress you probably wouldn't want in your house. Chairs that are ripped to shreds. Uh-oh. No, not bleeding yet. Bowflex, that's actually interesting. I don't need it, but that's an interesting item to be for free. A couch no one wants. Jars you can clean out, dirt, pallets, cardboard boxes and books. A tiny bit of scrap that's already gone. I guarantee you that heater's already gone. Concrete chunks because they don't want to pay to dispose of them. Scams. Kittens, you can get those a lot here. This is unusual for a shelving unit to be available, but there's no shelves. Bed liner for a truck, but only if you have that specific truck. This is a common one. Roosters. I'm trying to find somebody who will dress a rooster for me if I give them 2 to 1. So you pluck and clean a rooster for me, and you get to keep one yourself. So I give them 2. They give me back 1 bird ready to cook. I'm hoping to find somebody who'll do that because I see roosters all the time, and I have an electric car, so I could very affordably go and get these roosters pretty cheap. And if I could find somebody who will dress them for me, in exchange for free birds, so I'm trying to find somebody who'll do that because I like free chicken. Free tires that he doesn't want to pay the dollar fee to go to the transfer station to dispose of. More free boxes and packing paper. That's actually a halfway decent looking couch, but it's torn. You can see there's rips in it. So he doesn't want to pay the $5 to dispose of it at the transfer station. So it's for free. Free scrap wood that he doesn't want to get rid of. That's actually a halfway decent couch, but it's fabric, so you have no idea if it's got critters in it. I mean, this is the kind of stuff you get for free here. Free concrete post. They've already cut the post off, so you're basically buying his concrete junk. Basically, the only stuff that gets away for free here is stuff that nobody's willing to pay them for, and they don't want to spend the money to take it to the transfer station and pay to dispose of it. So they're hoping they can trick somebody into coming and taking it for free, and now it's not their problem anymore. That's the kind of stuff you get for free around here. If they think they can get $5 for it, they will hold on to it until they get $5 for it. That's actually pretty nice. It's actually a nice desk for free. You don't see that too often. It's probably already gone. This table has been outside all its life. You can see it's bowed in the middle. It's been sitting out in the rain. Okay. Um, this is the kind of stuff you get. Mattresses nobody wants because here you have to pay a fee to get rid of a mattress. It's like $1 a mattress or $2 a mattress or something like that. So you have to pay to get rid of it. They'd rather trick somebody into taking it for free. Oh, I wouldn't catch it. No way. It'd be a big net, man. I can't run fast enough to catch a chicken. Where's my roommate? I got him! Oh, man. Here's a free food processor. That's one of the rare, uh, not junk things. But, that's a $10 food processor. I just literally just bought this food processor for $10. It was a good deal. I want to make some pesto sauce. But yeah, yard sale leftovers, stuff nobody would buy, pallets, stuff that you have to pay to get rid of because nobody wants to spend the time to tear apart the pallets to use them as firewood, so they tend to be free around here. Prickly pears would be pretty cool, but they're hard to transport, and he probably wants you to dig them out. Yeah, you pick. So he's got this plant that he wants to get rid of, and so instead of paying somebody to cut down and pull the roots out, he's hoping somebody wants one bad enough to come and do it themselves to pull that out. You see how big that plant is? Yeah, if they're 4x4s, if they're 4-way pickup pallets, they have to be the right size though. So with pallets, not all pallets are made the same, so to speak. Electric lawnmower, that's not bad. It's not a bad freebie. Oh, you actually sell the lumber. Well, yeah, with lumber prices the way they are, I can see that being a thing now. Yeah, I can see that being a thing. See, here's another free rooster. Now, this is kind of cool. If you want to have something to play with, keep an eye out for these old projection TVs. Okay? You're going to scrap it. Okay, you're gonna toss it all in the trash. You're gonna get rid of it. But one of the pieces of plastic that make up this screen is a Fresnel lens. You can do some really wicked shit with a Fresnel lens that big. Like you put that in you build a 2x4 frame like an easel, like an artist easel. You have to be careful with this. You have to make a cover for this. You cannot leave this lying around without a cover. Um, you put this in a frame, you point it at the sun, and you put a 2x4 at the focal point of the lens, and it will instantly light that 2x4 on fire. Instantly. Like, I'm not talking make it hot, smolder, burn, and maybe eventually catch on fire. I'm talking on fire. They're amazing. You could do some wicked shit with a Fresnel lens that big. Oh, they are dangerous. They are very dangerous, but very fun. I wish he wasn't in Rio Rancho. Rio Rancho's too far away. It's not worth spending gas to go get, but if it was close enough to take the trailer with the electric car, I'd do it. And I would just dispose of it in the garbage. It'd cost me $5, but I'd get a Fresnel lens. I get a big giant Fresnel lens. Oh man, the things you could do with that. Yeah, empty grain bags are pretty cool. You can do some cool stuff with that. See, dishwashers are a common thing around here because they're not very useful. The hard water. Yeah, you do. There's this one goddamn thing that I want really bad, Vaughn, and it keeps coming up on this little fucking island in South Africa. It's like, why does Facebook Marketplace keep showing me this thing in freaking South Africa on this island? Well, it's probably not South Africa. Here, I'll show you. It keeps popping up in my list. I get excited, I click on it, and then I realize it's freaking Africa. Oh my god, Facebook Marketplace does the dumbest shit sometimes. What are you doing? Why are you taking so long? Is that my connection being slow? Nope, bandwidth is good. Here we go. It's right off of here somewhere. There it is. There is there's a guy who's got a few propane tanks that I want. And it's either this island or it's this island. It's one of these islands right here. This damned propane tank keeps popping up on Facebook Marketplace in one of these islands right off this little curve here on I don't think it's this big one. It could be. But one of these freaking islands, it keeps popping up on let me see if it pops up again. It doesn't always pop up, but every couple of weeks it pops up when I do my search. And I'm like, oh, that's a nice tank for free. And then I click it. I'm like, what the hell? Where are you? And it ends up being that goddamn island in freaking Africa. Propane deep fryer. Nice. Yeah, it's not here now. But yeah, every couple of weeks it pops up in my search. And it's like, gosh, dag nagget, you tricked me again. Go away. That's a good deal for that tank, but still way more than I can afford. Plus, I need like 12 of them. Yeah, it's not going to pop up now. But every now and then it pops up there. It's so annoying because it always tricks me. I always fall for it and I click on it. And it's that island out in freaking Africa somewhere. Yeah, it's one of these islands right there. It's right in here somewhere. Yeah, one of the. I bet you it's that one. It's either that one or it's this one. I don't remember the words being over it though, so it's probably one of these two. Well, you're down cold part there. Actually, I guess that's warmer than the United States. That's closer to the equator than the United States is. Huh. It blows my mind, you think you think the southern United States, oh, hot and how, close to the equator it is, and you realize how far away from the equator that actually is. I mean, that's in your mind you think close to the equator, but then in reality you look at a map and you realize just how far away from the equator most of the US is. Incredible. The problem is it's people like us in the United States and people like this in Europe. We're so far away from the equator that we are insulated from the larger effects of global warming. We don't realize just how god awful hot it is for everybody living along here because we are so far north relative to the equator. It's incredible. That's all right. Hmm. Incredible. Like it looks like here, the entire continent of Australia is closer to the equator than any part of the United States except Florida, maybe a piece of Texas. I'm sorry. It's on. Go to Nerisse.com. It's there. 3D printing at Nerisse.com. That's Nancy Echo Romeo Sam.com. Nerys. So you can send it to London at Nerisse.com. And that'll work. Your last name at Nerisse.com. Oh, nothing. I was just mentioning that there's when you said South Africa, I mentioned that every now and then a propane tank pops up. It's not here now, but I do searches. I'm always looking for these 100-pounder propane tanks, and every now and then a propane tank pops up on Facebook Marketplace off of this island right here. It's like, what the hell am I supposed to do with that? Yeah, in my Facebook Marketplace for Albuquerque, it's either that island or this island. It might be this one. I think it's bigger than that one. I remember it having this ring road. So I think it's this one. But yeah, every now and then this propane tank pops up on Marketplace and I click it and it takes me freaking to here. It's like, why? Why do you do this? What, you live near this? I thought you lived down here. Well, considering that it's on the other side of the planet in Africa on an island, I'd say it's pretty far away. Hey, you know what's crazy? Is that this map does not do justice to what the globe actually looks like from space. Like, if you were to look at right here on a globe, you couldn't see any land. Like, one whole hemisphere of the Earth has no landmass on it. This here makes it look like we're pretty evenly distributed, but we're not. Hang on. Globe. There should be a way for me to see animated globe. Where the whole world looks basically empty. There we go. So if you look at it from the center of the Pacific Ocean, this is what you see. Almost nothing. You can just see a bit of Mexico and the US. You can just see Australia, and you can just see Antarctica. But from space, it looks like a water world. You know, there's Hawaii, there's Japan. No, not Japan. That's Japan's up here, right? What's down here? What is that? New Zealand. So you got New Zealand here, Australia here, Hawaii there, US and Mexico there. You can almost see South America over here. Oh yeah, oh they're totally wrong. So when you look at a map like this, all of this is tiny. On a map, Canada, Alaska, Greenland is huge. But if you know here, I'll show you. Overlay. So Russia is as big as 2 United Stateses. And looks like Russia is as big as and Africa is twice the size of Russia. And 3 Texases would fit on Greenland. But the better one is Greenland on the US. Where's that? Why do you got to make this so confusing? Here we go. Should have saw that. So there's Greenland over the US. Yet on this map, Greenland looks like it's 4 or 5 times the size of the US. But the actual size of Greenland is that big. Well, it's not a weird scale. What it is how do I describe this? What is flat? Okay, so this is going to be controversial, but the Earth is actually flat. What we call flat is a sphere. Because what we call flat is not relative to the object we're standing on. What we call flat is relative to the pull of gravity. And gravity has a spherical pull. Okay? If you had a landmass like this, with the gravitational force being here, then as you walked outwards on this landmass, you would begin to tilt like this, because you would be constantly getting pulled to that center gravitational point. So the Earth is flat, and flat equals sphere, because gravity pulls from the center, and so we stand upright no matter where we are on the sphere. So if I draw a straight line from this part of the United States to this part of Greenland, that's a straight line. But it's not a straight line. It's an arc. So if I look at it like this, I see a straight line. But if I then take that straight line and lift it up off the map and turn it sideways, it's an arc, because we're on a sphere. Well, then, how do you navigate with a map? If I take a straight line, look what happens. Take that straight line, which is actually an arc. Okay, that arc is this big. Okay? Now flatten out the arc. Well, now it's this big. So what I do is I scale and stretch out everything on the map so that this arc, which is the actual line from Pennsylvania to Greenland, is represented as this longer straight line on a flat map. By stretching out so that when I draw from here to here, well, what is the angle? Well, if straight up is 0 degrees, that's what, about 15 degrees? So I need to take a heading of 15 degrees. But that's not actually the way it works. Because if I take a heading of 15 degrees, I'm going to miss Greenland. Because that's 15 degrees on an arc, on a sphere. So I have to distort the map so that 15 degrees flat with a ruler on the map ends up equaling a 15-degree straight arc on a globe. And that's why the map is distorted. Now, the closer you get to the equator, the less the distortion is. That's why South America looks so small, and the top of Canada and the United States looks so big, and Greenland looks absolutely massive. Because as you approach the top of the sphere, all your points, all your lines of latitude begin to converge. So, for example, to walk around the Earth here, would be 30,000 miles. But to walk around the Earth up here, you could circumnavigate the entire Earth in a couple of feet. So let me show you. Here. See here? So as you can see, each of these squares on a sphere, these are a square. They look like a square to us because we perceive it as flat. But as you get closer to the pole, you can see these lines converge. See how they're really close together up here and really far away down here? So in order to make that arc that you actually have to form on the globe equal to a straight line that you can draw on a map to navigate your ship by, they have to distort the entire globe to stretch it out to make it more like flat, as if it was flat, so that 15 degrees on the map equals 15 degrees on the airplane's compass. Otherwise, they'd be different, and you'd have to adjust it based on where you were going. Now, today with GPS, we don't have to do that. But back in the old days, well, there was no way to make a usable, globe that was a high enough detail that you could have on your ship. You'd have to have, arced pieces of something on your ship, and you'd have to have a way of measuring on that arc. So instead, using the longitude lines, they distort it. So every line of longitude you go up, you stretch the continents out bigger and bigger. Yes, there is an orange slice map. Exactly. That's exactly the problem. So what they did was they took that basketball map, laid it flat, and then reconnected everything. And the result is the further up you go, the more oversized all of the continents become. And that's also why you need a scale chart to be able to tell how far away things are. But yeah, that was a consequence of needing flat maps that you could put on your navigation table in your ship and be able to take your compass and ruler and draw out a course that you want to take on the Earth and actually end up where you want to be. But how? How do you do it? Because you have a flat map that you're trying to superimpose on a spherical object. Well, the way you do it is you distort all the objects. So the further north you go, the bigger they become. So here you can see Greenland looks like it's twice, 3 times the size of the United States. But when you actually put them together, you can see the United States is actually 3 or 4 times the size of Greenland. You could put another Greenland here and another one upside down here and another one right side up here. You could almost fit 4 Greenlands on the United States. But because of the distortion necessary, the further you get from the equator, everything up here has to get bigger and bigger and bigger and bigger and bigger in order to be so that when you draw a line from here to here, that line is actually correct. That the distance is correct and the line is correct. That's why it has to get further and further away, because you're not actually traveling in a straight line from here to here. You're traveling in an arc. But that arc is so big, and because of the way gravity works and the way that we interact with gravity, we perceive this curved arc surface as being a flat surface. Because, well, the pull of gravity is always pulling us to the center of the Earth. Fascinating stuff. The whole history of maps is absolutely fascinating. But the core problem is, we don't teach people why this map looks like this. We used to. Well, at least in my school, we didn't spend very much time on it, and we didn't explain it a lot, but we did go over the difference between Mercator and the different kinds of maps that there are. But I think a lot of that was because I was in search and rescue training, and so I got taught a little bit more than that. I have a feeling that most of it didn't come from school. I think most of it came from Civil Air Patrol, where you had to learn that kind of thing in order to use a map correctly. But so everything at the equator compresses, and everything at the toward the poles expands. And we don't realize how much distortion there is because we don't realize how far north we are. And because they don't teach this stuff in school, people look at these maps and they don't realize, how distorted these maps are. They think Greenland's this big. I mean, don't get me wrong, Greenland is big, but it ain't that big. I mean, in this picture, Greenland's bigger than South America. And obviously it's not until you put them the correct size on top of each other. That's why a globe looks so different from a map. You look at a map and you go, okay, and then you look at a globe and it's so totally different when you look at a map or globe. Like here, see? Look how small Greenland is. You can see how tiny. Am I showing you the right screen? No, I'm not. So you can see here how tiny Greenland is on a globe. So here's the U.S., and here's Greenland. Yeah, I know. Iceland's green and Greenland's ice. But look, Greenland damn near touches the North Pole. It's all the way up at the top of the freaking planet. Jesus. That's incredible. But you don't realize the scale until you put it on a globe, and you go, wait a minute, that looks tiny. Why does it look so big here? That's why. The reason, well, the primary reason is so that if I place a ruler on this flat map to navigate from Newfoundland to Nanortalik, okay? If I don't distort the scale of this map, this heading and this distance will be incorrect. In order to keep this heading and distance correct on a flat map, we have to distort the flat map so that the resultant heading and distance on the map equals what it would be on the globe going from here to here. So in order to make this equal to this, we have to stretch it all out. Because remember, you're not actually going this from here to here. You're going this. And if you take this and flatten it out, it's bigger. So if I take this, this is 2.5 inches. But if I stretch it out flat, it's over 3 inches. So that's a big difference between those two. So to represent this arc on a flat map, it has to be further away. So everything has to be bigger. You live on the Arctic Circle? Where do you live? What, up here in Sweden or Finland? Or Norway? You live in Norway? Here's a trick question for you guys. How many countries border the United States? You guys know how many countries border the United States? 3. Russia. Is it this one right here? Is this the one that's split in half? One of these islands is actually split in half, and half of it is the US and half of it is Russia. I think it's this one right here. Is it this one or is it this one? So it's 3. The United States is bordered by Russia, Canada, and Mexico. And isn't there another one? Puerto Rico is its own island. So it's not like this is split in half, but this is 2 separate countries. Neither one of them is part of the U.S. Puerto Rico is part of the U.S., but it's its own state, country, territory. It's not split like this is. So 3 countries: Mexico, Canada, and Russia. Although Russia is only part of the time. Technically, you could argue that it's only when the water level drops that this connects. But yeah, I'd argue it's 3. Oh yeah, that'd be pretty easy to do. No problem. I'm going to get out of here too. I'm going to run to the post office. I got some cookbooks to pick up. I've been kind of going crazy on eBay with $4 cookbooks. I've been finding these beautiful, beautiful cookbooks on eBay that are I only like cookbooks that are all pictures. I want to see a picture for every single recipe in the book. If it don't have a picture for every single recipe in the book, I don't want it. I want to see what I'm going to eat. So I will see you guys later. I should have the batteries have shipped, so they'll be here soon. Um, I gotta find the charge controller, but I'll have all the wires, the switches, the buttons. I've got the LEDs. I'm gonna start printing the parts. So hopefully next week we'll be able to put this flashlight together. I just think it. I mean, like I said, it's not to be a cheap flashlight, because if you want a cheap flashlight, then you buy this for $1.25 at not a Dollar Tree. Sadly, Dollar Tree doesn't exist anymore. Now we have not a Dollar Tree. But my point is to make one flashlight that I can make myself, that I can repair and service myself at a reasonable price that will last a very long time. That'll basically be everlasting. And I just think it'd be cool to do that. Just, just, I'm tired of seeing consumer crap that's designed to be used up, wasted, thrown away, and then replaced. I'd like to see us start making stuff that, believe it or not, this is, I would call this a biffle flashlight. I mean, it's simple. There's nothing that's going to fail in here. It's a resistor and an LED, and it has a little core. I call them warp cores, but it's got a little core, and you can replace the batteries. I wonder if we can even make an adapter to run this off of a lithium battery. Theoretically, that should be possible. I mean, the voltage is about the same. Well, at this load, it's a little bit lower, but I think close enough. But it'd be neat to just shove a lithium battery up inside there and be done with it. But I want something that's versatile, it's easy to charge, that's batteries that'll last decades instead of years, and something that can be serviced and repaired, upgraded. Um, I just think I'd like to see people push toward more of that. I'd like to see people do more of making stuff designed to last, making stuff not designed to be disposable. And interestingly enough, the most disposable hobby in the world, almost 3D printing. I mean, how many failed prints do we throw away? Okay, it'd be nice to see us use 3D printing to make truly long-lasting, usable, serviceable, non-disposable products, stuff. You know, not really designed for you to sell, because who's gonna pay me $100 for this flashlight when you could buy a very nice flashlight off of Amazon? Nobody's gonna pay me that. But the point is, you make it yourself. PLA is theoretically biodegradable, but in practice, it's not. You can bury a 3D printed part, and in 10 years, it'll still be as good as the day you buried it. Now, maybe industrial level composting might be able to biodegrade it, but for all intents and for the purpose of us, it's not biodegradable. You can't stick it in your compost bin and biodegrade it. It's not going to work. It's better than plastic and polystyrene and styrofoam and stuff like that. But you're not going to backyard compost it. That's just not going to happen. Not enough heat, not enough critters. You would need a more industrial composting to biodegrade PLA. So when you say biodegradable, it's important to understand, do you mean backyard biodegradable or do you mean industrial biodegradable? Because they are very, very different. Especially out here where there's no water, it's going to be even slower without water. The pigments and dyes will degrade, so you'll lose color, but the actual plastic part, not really. Well, technically it is. It's made with polylactic acid. And one of the places you can get polylactic acid is corn. It's like saying Splenda is natural because it's sucralose. Sucralose is a natural thing. It exists in nature. But Splenda is not made from any natural source. It's a chemical concoction in a laboratory. So it's basically the lab is coming up with the same final product as nature comes up with. So technically, it's natural in the sense that sucralose is a natural thing. It's not natural in the sense that it didn't come from nature; it came from a lab. So same thing with PLA. It's made of polylactic acid, which is a derivative of corn or can be derived from corn, but they don't have factories tearing up corn to make PLA. Yeah, it's not going to dissolve. It'll outlive you. Now, is it good for the environment in that it will eventually degrade and go back to nature? Yes, it will. But you're talking decades, if not centuries, not next summer in your compost pile. Same thing with stuff like this, you put this in the ground in 100 years, it'll still be there. Well, same thing with this. Same thing with this. You know, anything that's truly biodegradable is not as useful to us. I mean, this is truly biodegradable, but how useful is paper structurally? You see what I mean? I actually want to go toward ASA ABS type materials for no other reason than I can't put this outside. If I leave this outside, if I bolt this to my house or my car, the sun out here is so brutal that the part's not going to degrade. It's going to soften and deform. It's going to melt. Not really melt, but it'll soften and warp. So for out here in the New Mexico sun, I need ASA ABS type materials. I think PETG might work for transparent colors, simply because they're not going to be absorbing as much light. But for something like a flashlight, well, if you leave the flashlight sitting on the dash of your car, you kind of deserved it. Because if you leave that sitting on the dash of your car, it's going to melt too. So I'll see you guys next week. Hopefully we'll put this together. I've already got the soldering iron. I got plenty of soldering irons. But I got this cool little micro USB powered one for $12. So I was like, that's kind of cool. I got the batteries just shipped today, so they should be here before next week. In fact, let me check and see what it tells me the shipping is. Batteries should be tomorrow. The batteries will be here tomorrow. The wires got delivered today. The 30 gauge silicone wires, because I want to use good quality wires. They'll be here tomorrow. The buttons will be here Friday, but I already have enough buttons to get the first one going. The solar lights for the blimp was already delivered. Yeah, so I should have everything I need by Friday, which means next week we should be able to assemble this and put it together. So I'm going to start printing the parts now. I'll probably print a couple of them. I'm only using 2 batteries, so I can make 2 flashlights with the 4 batteries that I ordered. And that's it. I will see you guys next Wednesday.